That's just it, Tim. They've got your family. No! Sorry. All right, anyway. Kerbal. ULA, Vulcan Centaur build. Let's roll. If we bring back the 1911, you know stuff's getting real. I think we should, Nader. Yeah, I said it. Oh yeah, I think we should. Bring back 45 ACP. EJ's gonna go armchair general on you right now. Think about how much less ammunition you have to produce if everybody has a 1911 with a full magazine, as opposed to a Beretta with a full magazine, or a SIG. Think about it. Yeah, 45 ACP requires a little more material, right? But less bullets. Just saying. Just putting it out there. 1911 mag holds like 4 rounds. 7. Thank you very much. I think we could take Canada with just 1911s. I do. Is it raining? Yeah, we're going to get a nasty rainstorm tonight, dude. 7 plus 1. Yeah, well, I'll talk about the mag. Yeah. There's +1 in the pipe. Yep. Yep. Think about how much less ammunition we'd have to make. All that 9mm, all that. What's that pistol cartridge? That what the heck did they switch to? No, it's still 9mm, but I think it's like what's the standard service pistol now? I don't even know anymore. I know it was the Beretta. It ain't the Beretta no more. It's like some SIG or something. Okay, SVL, that's good. It's a SIG, right? The SIG M18. All right, let me take a look. What does that look like? Yeah, that's kind of nice. Yeah, that's nice. It ain't no 1911 though. It's a P320. Okay. How many are in the pipe? Or how many in the mag? +1 in the pipe. $17 or $21. It's a lot of extra rounds. Just saying. 17 plus 1. 9mm? Is it 9 or is it like 40 S&W or something? It's 9mm. Yeah. Interesting. 17 plus 1. So, Victory, I have a dumb question, all right? And this is not me being an armchair general at all. I have a really stupid question. My stupid question is why do you need 17 rounds in the magazine on your sidearm? Just honest question. Like, what's the use case for that? You know, I get it. More lead to put down range. I understand that. Yeah, that makes sense, I guess. Like, is that the reason? Because 17 is more than 15. 5-7 for the win? For CQB fighting. Huh. Because if you need your sidearm, then you need as much as you can throw at the situation. Yeah, I suppose that makes sense. Because evil can't be dead enough. Good enough reason for me. You don't want to run out of ammo in a gunfight. Yeah. World. Yeah, that makes sense. 17 fits without compromise. I mean, it makes sense. No, that's perfectly good. I mean, I just want the 1911 back because I'm a 1911 fanboy. Like, let's be real. That's the reason. But yeah, I suppose, yeah, if the combat situation devolves enough to warrant using a sidearm, you're just going to want to like, get the frick away from me. That kind of makes sense. I get it. For when switching to your pistol is faster than reloading. If you're putting lead down range, the other guy is hiding and not actively shooting you. Yeah. Yeah, SVO. Me too. Yep. Get the frick away from me. Bop, 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 bop. One of the big lessons that we learned in World War II was that success correlated with the number of rounds down range, not accuracy or stopping power when the poop hits the fan. I know, Bandit. Yeah. Zay, you just got here. I went on a gigantic rant today, basically just stopping now, about how a delay like this is starting to show the glaring problems with SLS's design and testing regime. It's not comprehensive enough. It needed to be like Constellation, and it's not. We think we can make a capsule that can go back to the moon just willy-nilly when the institutional knowledge for making said capsule left us 50 years ago. We somehow think that we can do a design and testing regime that's tighter than Apollo with an infinitely more complicated mission architecture. Even Starship notwithstanding. And I think that shows. Yeah, that it's starting to really show. If it's all about putting lead down range, then why not just use a machine pistol, an SMG? Tessa, you know an SMG is just an automatic weapon that's chambered in a pistol cartridge, right? Machine pistol. Is this Destin's fault? Maybe. P90 go... I hope this doesn't result in dead astronauts. And man, I don't think it's necessarily going to result in people getting hurt. What I do think is going to happen is at this point, I don't really have much confidence that 2025 is going to stick. I hope I'm wrong. I really hope I'm wrong, and I hope I eat these words later. To be honest with you, you shouldn't be having problems at this point. You should not. You should not be having problems. Like I said, Artemis 1 was the final exam, dude. There shouldn't be any problems. You don't learn anything during a final exam. It's to test your abilities, right? We're testing the abilities of the vehicle against the the analysis of it, right? That's the whole thing, right? That's the reason. Having problems now means you didn't get a good grade on your final exam, and it was enough of a bad grade to warrant summer school, basically, in the schooling analogy. It delayed the launch by a year when we're a year out. Red flag. I don't necessarily think that is cause for concern when it comes to the crew. I think that's it's a good thing to be able to say, like, look, this thing's not good enough. It's not good enough. We need to work on it more. But we're going to push that mission out a year from its launch time, which is a year from now. So it's 2 years from now. Now, when will then be now? Soon. We're going to push that mission out that far. Not do any test flights? Nothing? No analysis. Yeah, you're going to do analysis on Artemis 1, and you're going to do analysis on the capsule that came back, etc., etc. But no more test flights. How are you going to validate this data? How are you going to know for sure that the heat shield won't do this when people are on board? Maybe 12 months is enough. But how do we know that's not going to happen with Artemis 2? How do we know that that's not going to happen in a year from now and they're going to say, oh, never mind, it's 2026? You know, one of the reporters in Mana asked that question. What makes September 2025 for Artemis 2? What makes that firm? What makes the lunar landing in 2026 firm? You just keep moving the date around. And Jim Freeze said, well, every commercial contractor here... And that was actually Eric Berger's question. Discovery. And I think that's a fair question. Honestly. I think it's fair. How do we know that we're going to get a year down the road and you're not going to just be like, oh yeah, we found more problems with it, it's going to be another year? when has contractual obligations, right? NASA has not held a contractor accountable in a long freaking time. What makes what makes us think they're going to start doing that now? Just because you said it? The talk is cheap, man. That doesn't mean nothing. Hey, Blue, that's 100 months. Thanks, buddy. I don't think it's going to be around July 2029, Tessa. I think at the rate that we're going, it's probably going to be 2026 or 2027. I think NASA is kind of on with their estimates, but it's not a really good look when you're supposed to be in iterative waterfall development and you run into this many problems, enough to warrant a 12-month delay. That's not a good look. That's not good at all. Chat, stop riling up EJ. Wiz, I have to sit here and be patient and explain it because I think it needs to be said. Start with a deadline in the announcement speech. So a more robust emission architecture from the start, Bill, like Constellation, would have been a better idea. Yeah, agreed. Do they have enough engines to do many additional tests? Vex, they have enough engines for Artemis 1, 2, 3, and 4. See, this is what I mean. Big red flag. We locked ourselves into this mission architecture. So if something goes wrong like this, doing additional testing, significant delay. If we had a more robust testing regime, maybe this would be maybe we wouldn't have this problem. I mean, Vex, actually, the answer to that is no, we do not. The next SLS flight is going to have people on it. And it's pretty damn clear that they ain't ready. They should yeet Artemis 2 as originally planned, but make it a second unmanned test flight to validate their fixes instead of delaying it. I agree, Nader. I agree. Yep. Yeah. What is this, Erudite? Yeah. Okay, here we go. Safety is always NASA's #1 priority. That's why today I announced NASA is adjusting our schedule to target September 2025 for Artemis 2 and September 2026 for Artemis 3. Yeah, okay. Sure. I missed it. What didn't you like about Bill? Oh, that's right. I never said it, Doom. What did Bill do in that meeting that pissed me off? Forced Jess to answer the question. Yeah, Jess Jensen, the SpaceX rep that was at that meeting. You know, they asked her about how many flights, and she said, okay, our architecture's based off this, based off this, based off this, based off this. And then Bill interjected to get her to say on the record that it could take up to 10 flights. That was a dick move. Yeah, that was a real dick move. Yeah, not cool. Why would you do that? I don't see you doing that with any of the other questions. Why'd you do it with that particular one? That's weird. I know we don't need more bad news today, but it keeps piling on, bro. Non-space related. Twitch is laying off 500 staff, representing 35% of the company. Alex, you want to start a hot dog stand? We could probably make good money off of that. Want to start a hot dog stand? We could do it. You and me, buddy. You and me, buddy. It'll be right on the strip. It'll be great. Hot dogs and lemonade, bro. We could do it, man. We could do it. To place blame on someone else instead of themselves. Yeah, Sledge, it's pretty cringy freaking behavior. I really don't like that. It's like he made Jess say that to show like, oh yeah, we're not the problem. Bro, your life support system doesn't work. Your life support system doesn't work. And neither does your heat shield. SpaceX is not the problem. Okay, let's be real. That's yeah, Sledge, I think that put into words. That's why that pissed me off. Why would you do that? What a dick move. Also, hot dog stands. Hot dog stands, bro. Yeah, I know, Bob. It'll be great. Yeah, Doom, that was not cool. That was not a cool thing to do. I tried a pulled pork barbecue sandwich stand once. Broke even. Ate pulled pork for a month. Nice, dude. Nice. Nice. That's a good idea. Spills this energy knows how to reflect bad stuff of him and onto other entities. I don't think necessarily that's him. I mean, maybe it's him deflecting Bandit. I mean, what Sledge said, yeah, that sounds right. But if you really want to know, the honest opinion why I think he did that was to garner support for the Sustainable Lunar Development Program. It's to garner support for SLD, which is the competing lander. Well, not competing, but it's the other lander. The legislation that they just made when Congress figured out that NASA was picking SpaceX for the human landing system. I think he did that to get some support on the record for why we need to fund another lunar lander. I don't like that because guess who takes your astronauts to the ISS, pal? It's a real dick move. You know, I wouldn't be surprised if Jess was pretty pissed off by that. That was a really messed up thing to do. But hey, whatever. What do I know? Rain. Nice. Nice. Safety is always NASA's #1 priority for going to the bathroom. To be safe, we need you to put a seatbelt on whenever you go #2. Because safety when pooping is our top priority. Oh, they're moving the GSE tank. Cool. Safety is in the pudding, especially when the pudding is chocolate and comes out your rear end. Sorry, I shouldn't have said that. That was mean. Hey, doing a tank lift. Nice. Okay. Shall we get back to Vulcan? Also, hot dog stands. Rockets are hot dog shaped. See? I'd be good at it. Yeah, Tessa. Safety is our #1 priority, especially when Jeb runs out of snacks on the moon. They were using thermal lances to cut the first water tank. Word. We're building a hot dog stand now? Yep. What kind of hot dog you eating? The good kind. You know how many foods are hot dog shaped? The best kinds. No popsicles, can't do that. He sees this lunchbox treasure trove and he freaks out. Joe, that's good. Nice. Oh man, now I'm hungry. All right, let's get the tunage back up. What's the mission? I'm going to build out Vulcan. ULA's Vulcan rocket. That was the plan. That's what I wanted to do today. We started talking about what we wanted to get done, and then that NASA announcement came along, and yeah. Here's something fun. We're both staring down storms. Staring down storms and then rant. Oh, nice. Then rant. Dude, it needed to be said, man. Hot dog 3D modeler, paid mentorship stand. It's a good idea, man. Instead of like bits, bitties, it'll be dogs, chili. It'll make sense. I mean, it'll make sense, dude. I got it all figured out. We're good. Man, they be drifting those vehicles. They do be drifting those vehicles, though. What's this? Oh, some hot dog buns. Hey, don't you already have a lot of those already? Shut up. That's Alex. I don't know if much of my chat's gonna get it, but you know what? It's funny to me, and you know, you laugh, so whatever. Flight canceled to New York. Stay safe out there. Hey, Natch. Yeah, we're getting a nasty rainstorm. Big wind gusts, dude. Bits. That's Al. I missed a golden opportunity the other day to say that when you gifted some subs. And you know what? I was walking back from the garage, and I stopped for a second and I went, oh, damn it! Oh, crap! Not even kidding. That absolutely happened. NASA solicitations for small business initiatives came out today. A lot of lunar tech, which is nice to finally see. It's a bit worrying to be how few lunar-oriented tech solicitations there have been in the preceding years. Well, that's good. I hope I don't have to go to work tomorrow. I don't want to drive a 40,000 pound box truck in bad weather. Yeah. Bits. Yeah. Last report was on 110.21 gust 47. Yikes. I was in the cockpit looking at the captain like, really? Then we got a message from dispatch that the flight was canceled. Yep. Yeah. I have the Yakuza 0 soundtrack burned into your brain. Dude, I'd believe it. Yeah, that happens, dude. I got the Cities 2 soundtrack. I find myself humming it off stream, and I'm just like, stop it. Heading 110 at 21 knots. Yeah, I got you. With gusts of 47. Yep. 47 knots? Airnock, yeah, since he is, no good. Yeah, I gotcha. Is the power and propulsion module still on track? I think so, Xerox, yeah. Don knots, 47 knots, that's no joke. Yeah, instead of 47 buckles. Yeah. Yeah, you know what, Natch? I'm going to go ahead and say that it probably would be difficult to land a plane in a 40-knot crosswind. Yeah, I'm going to go out on a limb there. You know, not a pilot, but, yep, that seems like that would be complicated. Yeah. Nader, yeah, it sucks. I came home from Hawaii yesterday to this crap weather. 80-degree sunny days on the beach to 45-knot winds and crazy rain. You did put an offer on property there. Wow, good. Look at you. I would describe it as challenging. Yeah, okay. Yeah, that makes sense. Actually, Nat, you know what would be cool in Kerbal? To take an aircraft, right? Take a plane that we have and literally just put a jet engine on the side lined up with the center of gravity and then try to land it with that jet engine firing. to show how much of a pain in the butt it would be. You know what? Can I? You guys mind if I just take 5 here? I gotta come down from that freaking rant, dude. That rant pissed me off. We gotta do something funny for a second. Then we'll get back to Vulcan. Do it? Yeah. Good call. Here we go. The Curb Bear 990. Where's our center of mass here? Yeah, there we go. Yeah, okay. All right, here. Let's just do a little bit of this here. Put an intake, put a mount right there, and then actually we'll do it in symmetry, right? We could do this in symmetry, and we could go from either side. There we go. Yeah, this is a great idea. This is a great idea. This won't end bad at all. Yeah. This is the crosswinds. Use a Weasley, not the Juno. I think that would be good enough. The crosswind center of pressure would be more towards the tail because of the surface area, right? Yeah. Yeah, you're right. Oh God. So, what do we do? What would be right? Doing? Oh gee. Oh jeez. Oh my goodness. Actually, okay. If we look at like what would be a drag coefficient from the side. Our center of pressure is probably, yeah, it's probably right around there. Oh God, this is not gonna end well. All right, I'll try it. It's kind of weird to me that we've never done this before. This is actually a good idea. Probably a little bit up more. Yeah, okay. Yeah, that's fair. Just a smidge, like right there. Or a midge, I don't know. All right. This will end great. This is a great idea. This will just be our quick little side hot dog stand project. You know what I mean? Be a little hot dog stand. Drag coefficient from the side is cursed. Are you gonna crab it? Yeah. Yeah. All right. This is fine. This is fine. Nothing bad will happen from this. A smidge. Yes. Precisely. I needed to get that stuff about NASA out of my system. Okay. All right, ready? We need to set control point. Hold on. Okay. Control point is set. APU is on. We are generating power. Okay. Informative and cathartic. Yeah. Yeah, we got a lot of power here. Did we check the door pins on this plane? No, why would we do that? Alright, right here. Ready? Activate. We need independent throttle at 100%. Whoa! Whoa! Oh, that's weird, man. Yo! Okay. Calm down. It's fine. Whoa, that sucks, dude. Alright. Okay. Alright. This is my crosswind simulator. So that motor shooting off the side is simulating a crosswind here. Wow, that sucks, dude. This is already a pain in the butt. Alright, let's get on the approach for runway 9. It's supposed to look like a Convair 880. That was the idea. It simulates Dutch roll. That's not... Dude. Yeah, no, that's... Yeah, it's doing it, man. It's definitely doing it. It's definitely doing... Dude, that's actually... That's not bad. Alright. Okay. Alright. Throttle us down. Alright. Flaps. Oh, okay. Alright. Relax. Dude, it's so easy to roll this thing over. I don't know how, like, it's very weird that's... The technique is to align the trajectory, not the cockpit. Yeah, I'm not sure if I can do that. I might not have enough deflection across my control surfaces, dude. Bro! This approach is bad. This approach is bad. I need more deflection on that. I need more deflection with the rudder. Dude, this is hard. This is hard to control. That force being applied to the plane completely changes your input. This is a terrible approach on my part. Oh, okay, relax. No. That's hard, dude. That is more difficult than I thought it was. Whoa. Whoa. That sucked. The Juno is on independent throttle. It's just going, man. Did you build it with rough field capability because you're about to land in the weeds? Dude, that's tough. That's no joke. The tower has a number for you to call. Hey, it's a crosswind landing. Give me a break. Alright. Dude, that's nuts. So, Natch, does something like that happen? Like, if you try to... So, what happens is I'm trying to put in yaw to compensate. To get the nose... To get the trajectory to line up and the nose to kind of be offset, right? To do that. But if I put too much yaw, the plane just flips over. Like, I know that's a thing like flying. If you input too much yaw, the plane will start to roll. Like that, right? I get it. But that was nuts, dude. That was crazy difficult to get that right. Whoa! Okay. I think RCS might be better to simulate a constant side thrust. Why would that be better than a jet engine? This honestly isn't even as strong as I've seen Crosswind. I think the engine needs to be further back. On commercial airliners, it's not recommended to use the rudder so close to the ground for that exact reason. What I do is I use ailerons on 1,000 feet to the ground. Okay. 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 Alright, let's try it again. Let's bring her around. You lose altitude really fast when you input too much rudder in a crosswind. That is exactly what just happened. The plane started to sink and I went, no, no, no! You know? That's cool. Like, you know, I mean, this is an approximation, but it's the gist of it is there, which is pretty sweet. Bank angle. Bank angle. Bank angle. Dolby, did you miss anything good? Just me ranting about NASA for a little while, but other than that, we're good, man. Yeah. I just fired up Kerbal a second ago. The Kangle. Alright, pause for a second. So... take out that extra rudder that you added. Yep, yep. It's okay if you touch the ground with the cockpit not aligned to the runway. The fun part is landing, and you feel the inertia of the plane wanting to go with the wind, and you feel the pressure on your body to not have it do that. Sorry, I missed the rants. Bill, the general gist of it is that with the delays announced today, I think Artemis's flight testing criteria is trading on institutional knowledge that we don't have. Long story short, it's pretty damn apparent we do not know how to get to the moon. At least in practice. Theory, oh yeah, the theory's there for days. But the institutional knowledge for how to do that waved bye-bye a long time ago. And it's starting to really show. Artemis's flight testing regime not being robust enough is really gonna... if it's causing problems now, it's gonna cause problems in the future. And what worries me is that it's gonna cause problems in the future when people are in the loop. I don't like that. I don't like it. I've never liked SLS's testing regime or architecture. Particularly when it comes to upper stage and what the vehicle is doing. Not necessarily the vehicle itself. I think the vehicle is fine. I think the core stage and the 5-segment SRBs are a great foundation for a great, robust space architecture. Launch it more, needs a higher energy upper stage. Yep. I kicked the rudder and aileron in about 30 to 50 feet in this 777. Okay. Ignore that, fly the prograde marker. Alright, gear down. Come on, baby. Stall. Come on, baby. Oh, that's so weird. Dude, my brain just defaulted to nose orientation, not prograde orientation. I just defaulted to it without even thinking about it. Wow, that's strange, man. Yeah, no, I instinctively just lined the plane up with the runway, and I started going that way. That was weird. Sucks. Come on. Oh my goodness, this is really, really hard. Whoa. Jeez. That's tough, man. That's really difficult. Whoa, I didn't think this would be this hard. Holy crap, that, wow. Like, I knew this was tough, but damn. Are you using my joystick? Yeah, I am. I have a 3D Pro, and this is a mild crosswind. That's hard, man. That's really not easy. What the hell are those things doing? I'm looking at our manual and we have 3 ways of landing in a crosswind. Decrabbing, kicking the runner in and maintaining the wings level. Landing in crab, and landing in a side slip with wing down to prevent drift. I prefer side slip wing down. I'm sorry if I laugh. No, it's fine, it's fine. Dude, I'm telling you, it looks like I'm just gyrating the plane around. Like, it looks like I'm kind of doing it on purpose. It's really hard to get that right. That's strange, dude. Yeah, that's really weird. Really counterintuitive. Wow, that's bizarre. It's like you got wind shear. Yeah, I know. I wanted to see, because it's windy outside in real life, or outside my house right now. It's windy in the northeast part of the US, so I put a jet engine on the side to simulate crosswind. It's working, dude. This is hard. This is not easy to do. What would be the analogy to more lanes, bro, in this game? More boosters, bro. Just one more booster, bro. One more booster, bro. One more engine. One more wing, bro. Yeah, I have a jet engine on the side to simulate crosswind. That's why I can't land this plane. I designed this plane to fly really easy. It's real easy to fly, except when you have crosswind. Wow. That's crazy, dude. That's not easy. Yeah, this plane was supposed to be super simple. It's very, very simple to fly. It's modeled after a Convair 880 because that's one of my favorite passenger planes. Well, more particularly a 990, but it doesn't have the pods on the wings to be a 990, but whatever. DC-8, 707, Convair 990, pick one. Add a cow with variable thrust to simulate wind shear. Oh, God. Landing craft is recommended on dry runways. On wet runways, it's better if you land aligned by applying gentle pressure on the rudder just before landing, but not too much because you can hit the wing. But that's crosswinds 102. Okay. Alright. Set the flaps. You can do it. Yeah, I got it. I gotta get comfortable with it, man. I gotta figure out, like, what's going on here. Alright, gear. Fly safe and don't lose your door. Yeah, that's probably a good idea. I just wanted to tell you, good luck. We're all counting on you.
Discovery, go at throttle up.
What's up, Ish? Hope 2024 starting off well? Yeah, it's not bad, dude. Jesus! Come on! No! Bring it down! Bring it down! Oh my God, that's tough. Wow! Whew. That's really not easy, man. Hot dog 1. Yep. Cleared the taxi. That's tough. Dude, I thought I had her down, right? I thought I had it down, and that jet engine just pushed the plane right back up in the air. That's weird, man. Wow. That's weird. Forgot to tell you, full aileron to the wind. Yeah. To prevent that. Ah, yeah, okay. Dude, that's tough. That's really tough. Dang. That's like a normal landing for Frontier. Oh, jeez. Alright. Further back. So, I don't know what the exhaust velocity is of these parts. I have no idea. Maybe you got it on point. Congrats. Oh, thanks. Last. Okay. Now, if you want to really up the realism, use a rocket engine and infinite propellant and have its independent throttle on a cow a minute or so long with random spikes for the gust. That's what Papa Bear was saying to do. Superman gifted us something to Natch. Thank you. Alright. Let's do this again. This is gonna get a little bit nutty. Oh. Okay. Okay. I might crash the curb there. Should the title get changed? We can do Vulcan in a second, man. We're not going to be doing this for the rest of the night, so that's all good. All good. Even just putting the Juno on a cal for gusts wouldn't be too bad. Let's just start with a constant crosswind so I don't, you know. Okay. Now that was steady crosswind. Let's try gusts. Dude. Nah, I'm good. I'm good, thanks. This should look more like a crosswind. Alright, let's try it. Yeah, we'll land on runway 27. Okay, let's turn and get on approach. Where's this airport located? Kerbin is an Earth-like planet, Pigeon. There's no real bearing on it. An airport like this, I guess, would be... If it was on Earth, it would be somewhere near the equator. But we're on a planet that kind of looks like Earth, but actually isn't. But the cool thing about Kerbal is that I could fly anywhere. I can fly anywhere as long as I have the fuel. Fly anywhere on this planet if I want to. Fly up to the North Pole, go see some ice sheets. Got an entire world to explore. And then you can launch into space on top of that too, which is actually super cool. And if you have the time. Well, yeah, of course. You might see a UFO? Yeah, maybe. Echo Juliet 154 requesting permission to land KSC runway 9. Did you already show those build mechanics you were talking about the other day? No, Cake, I haven't done that yet. Yeah, I am, CJ, yes. Does that mean you could build or design a plane to refuel in flight? Only problem is you can only control one vehicle at a time, Bob. I could design a refueler. I would need one of the Kerbal multiplayer mods so another person would be flying the plane around. Yeah. Alright, let's do this. Ready? Ah! Okay. I'm too high. You shouldn't really do this. Trying to adjust your approach mid-approach is generally not how you plane. I mean, you can, but... Yeah, we were way too high up. You can if you like FAA coffee. Yeah, there you go, right? Okay, let's bring the nose of the plane up. See if we can set our descent rate. Okay, give it some throttle. Stall! Ground altimeter is on. Come on. Ed boy. We got it. We got it. We got it. We're good. That's tough, man. That's not easy. You really have to be laser focused on that runway, that's not a thing. You shouldn't like get target fixation like that in an airplane, but you have to. I have my license, man. You're fully qualified now. Well, I'll be dipped. That's hard, man. That's really not easy to do. Yeah, dude, I brought it in and turned it at the last second. Like, oh man, that's weird. That's strange, dude. That's real strange. Also, I think the nose of this looks like hot dog crap. We could probably do with a detail pass here. That looks terrible. Yeah, here, you know what, Natch, I'll show them. This is what I'm trying to do. Okay, yeah, we don't care what you got. Shut up. Turkleton.
180 degrees, 26, gusting
watch
40
this.
knots.
It's supposed to be something like that, Serge, yeah. This is from Mr. Aviation Guy. Yeah, see? That's hard, man. That's really, dude, you really have to stay focused. And then you realize that plane is flying sideways. Oh my goodness. Oh my goodness. Oh my goodness. What are you doing? How are you doing this? That's impressive, man. Wow. Can I see that one more time? Hold on. That's savage, man. You know what? Had a landing like that in SFO once. Not near as intense, though, but it sure felt like it. You know what? You know what we're doing? Here's what we're doing. Let's try something. Center of mass, center of lift. Find the root part, set it to absolute, turn this thing this way. That's where our center of lift ends up? Huh. Interesting. Okay. Alright. Difficulty level. Yes. What this is showing right now is basically the wind coming this way and where your center of lift and center of gravity is. If there was a crosswind in KSP, the original spot where we had it was pretty much right. All right, here we go. Why use a wind mod? This does it just fine. Yeah, Porter, that's right, dude. You got it. Yeah, exactly. I'm pushing. I've been moving the crosswind thing back further and further off the center of gravity each time I try, just to see. Right? Like, I want to see what happens. Why engines on both sides? So I could simulate wind coming from either direction. Yeah, there's... Like, we don't, hang on. Yeah, we can, here, we'll go. I could shut off one side and go on the other side. Whoa, hey. Hello. See, without the crosswind thingamajigger, this plane is actually pretty easy to fly. It's not too bad. Should probably shut the APU off, though. Alright, let's turn her around for an approach. Crosswind simulation is on. Slow her down. Alright, we're bringing her around. That doesn't look like Vulcan. I'm testing something real quick, 95. Also, you don't look like Vulcan. Got him. Okay, 94. Gear down. Is this a max 9? No, the doors are still on. Got him. Do it from the cockpit? Okay. Ailerons are having trouble compensating. I'm putting slight yaw in to get this right. Oh, stop, 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 stop. No, it's no good. Go around. Damn, that's tough. What I like about this is that your threshold for going around is on point. Congrats. Like I said, Natch, I mean, I've said this in the past. You put me at the helm of an airplane. I'm pretty sure I could figure it out, but yeah. Like, could I get a 172 up in the air? Sure. Absolutely. Yeah, I can fly that, no problem. I'm confident. Would I know exactly what to do when I'm in the air? Would I know how to talk to the tower or anything like that? No. No, probably not. Should try Kerbal VR at some point. Yeah, maybe. Are you going to do Flight Sim tomorrow? Oh, that's a good idea. Get an ultralight and wing it. I see what you did there. No license required? Yeah, man. I know this is about planes and rockets, but could you make a space elevator in it? No. The game just wouldn't be able to understand what you're doing. People have tried. People have made really big freaking structures like that, but no one's made a space elevator, dude. It's really about building rockets and aircraft and stuff. Where's the stat about how 70% of men think they can land a plane? Yeah, but how, of that percentage, how many of them can actually land it? I'd get the plane back on the ground. It won't be a pretty landing, but I could get it down in one piece. Right on, Natch. Right on, man. Gracias, amigo. Mucho queso. Por favor. Dame un queso. Ahora. Rápido. Gracias. Gotta slow down here. What does pushing the flaps down do? Deploying the flaps random basically has the wings generate more lift at the expense of airspeed. The flaps down means that the plane is forcing the air going underneath the wing. It's forcing that air down, which keeps us afloat, right? But the wings also make way more drag this way. Because the wings make more drag, you need to throttle the engines. Unlike what I'm doing right now, and I just stalled the plane. I gotta throttle my engines up to keep me going in that direction. Predominant retrieved add time. All right, let me put this bird on the ground, then we'll roll. So, guys, I have a jet engine on the back of this plane simulating basically a crosswind. I just wanted to see how well Kerbal understands what's going on. It's actually not bad, from what I can tell. You should add flaperons and spoilerinos. We could. Too high. We gotta get lower. Does KSP have leading edge slats? I could put them on there, Porta. Basically take a control surface and put it on it, dude. Whether it would work exactly like a slat, I don't know, man. Maybe. What's the airspeed? 62. Alright, we're fine. My phone's going off because of course it's going off. Oh crap. Nope. 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 Get out of this. Freaking phone was going off. Would it work in Ferrum? I don't know, maybe. It's not bad, but because of the lack of ground effect in KSP, the true complexity of crosswind isn't quite replicated. Yeah. This isn't like 100% perfect simulation. Yeah, the plane just did that, by the way. I didn't bank it that hard. Are action groups able to enable and disable the flaps? Yeah. I could, if I AG'd them. Maybe one thing that we could do is a detail pass on this aircraft. Make the cockpit look not stupid. Not like it's been broken. Alright, let's try this again. What are you doing, EJ? Selling airplanes. Road building takes a long time in CS2. Pigeon there, yeah. It took me a long time to build that frontage road highway, man. You remember that? Alright, let's try this again. Hey, Adam. What's going on, man? You'll like what we're doing in here right now, dude. Is there wind in this game pushing you? No. There's no wind in Kerbal Space Program. What there is what there is a jet engine that's over my, that's mounted under my vertical stabilizer. One of them is on and the other one is off. That thing is at full thrust and it's kind of replicating a crosswind. I just want to see how this feels. It's not an exact replica, but it's good enough. So, yeah, I got a jet engine on the back of my plane that's wanting to push the tail out from behind it. And I'm trying to set up an approach here on runway 9 at KSC. This is not as easy as it looks. Sure, Charles, yeah. I'm gonna set some trim over my elevators here. Oh, the SAS is on. There we go. You should put another couple engines in the front as well. Okay. Mile final for runway 20. Come on. Come on. Oh my god. Yep, we died. Not good. I think my wing hit. Oh. Yep, that is exactly what happened. Damn, that's really difficult. What's more accurate, Flight Sim or this game? Flight Sim. Flight Sim's way more accurate, dude. Oh. Hey! People are still alive. The white zone is for loading and unloading only.
Discovery,
There's no parking in the white zone. You don't compensate the wind with the rudder, but with heading. The rudder is used during flare to line it up.
Discovery,
Yeah. So Adam, what happens is I try to do this, and then the joystick ends up turning, so I always end up inputting a little bit of yaw. Yeah, that's what Natch was already saying. Don't use the rudder. You use the rudder in a crosswind, the plane flips over. Yeah, I figured that one out. Guess how I figured that one out. You don't have enough control authority? Yep. Okay. That's good enough for a job offer from Spirit or Ryanair. Oh. Dude, that's not easy, man. That's really, really not easy. It's not the fact that, like, I put the plane down on the ground, right? Like, I did it. It's tough because it's counterintuitive. Your brain keeps trying to line the plane up with the runway. That's what's happening with me. I'm like, okay, I got to turn now. No. You have to basically be pointed at the VAB until you touch the rear gear, and then you turn it. It's weird. It's screwing with my head a little bit. You gotta drift though it in. Yeah. You're not kidding. Yeah, that's tough, dude. That's really weird. The red zone is for loading and unloading. There's no parking in the white zone. The white zone is for loading and unloading. There's no parking in the red zone. You got a clutch kick before the wheels touch down. Dude, it's difficult. We can, you know what? Maybe for Wings Wednesday, we'll screw with this again more tomorrow. I think we should start on that Vulcan build. So, advanced building techniques coming at you. So what I'm hearing is that EJ needs pilot lessons for his birthday. Keep the touchdown zone in the same spot on the screen, provided you don't move the camera in IVA. Try IVA. I had an IVA landing, but right before you came in, Adam, I had one lined up. But, so what happens is I had us aligned. Like, we were coming in pretty good. I was flying this thing sideways in KSP, which is pretty cool. Like, it's pretty cool that it did it, right? I didn't get the trajectory completely lined up, and I would have landed on the side of the runway, so I chose to go around. Because I didn't want to do what you just saw. And then I ended up doing that anyway. Oops. That's not easy, man. That's difficult. It's really simple. Like, I understand what I need to do. It's just actually getting the plane to do it is really counterintuitive in my head. That's really weird. Yeah, that's hard, man. Have you heard of Flyout? Yeah, Porta, I've played Flyout, dude. Yeah. I played it on stream, dude. We built a T-38. I couldn't get my jet engines to work like a J-85, though. I think it's because I didn't model an intake form, which apparently that game you have to do. But I did make a T-38. It was pretty good. Dude, Flyout is an amazing game. Dude, Dad, you've not played Railroader yet. Are you going to remind me every day, man? Hey, that's pretty good. Flyout's a sweet game. But yeah, I made a T-38. I brought the orthographic images in. Actually, Porter, I can show you real quick, buddy. Let's get to that Vulcan build, though. We could talk airplanes tomorrow. Yeah, I was actually gonna boot up some flight sim, but we can play Flyout tomorrow. I wouldn't be against it, man. Where's Flyout? Fly out music? Yeah, look at that. How's that? Not bad, right? That looks like a T-38 to me. Looks pretty close. When you throttle down, also the tail engines reduce thrust, right? No, I have it set to constant. I have that set to constantly output 100. I unbound that engine from the throttle, so it's always going to be pushing. Damn, that's good. Where'd you get all those fuselage section pictures? Well, I found this orthographic picture of a T-38 and then we cut it up. Yeah, here.
Discovery, go at throttle up.
Okay, but when's the space elevator build? Shut up. Space elevators are technically VTOL, so because you're here, Akvi, I can't build it. Sorry. No puedo. Can't do it. I have to mess around with the nose a little bit, but for the most part, I think we got it, dude. It's pretty good. pero puedes comer queso? Sí, sí. Yo come mucho queso. Con burritos. What the fuck are we saying? Sorry, excuse my language. Anyway, yeah. Yeah, Porter. Maybe we can mess with that more later. But yeah, back into KSP. Queso con tortillas en El Salvador. Aquí con las cucarachas para 2 semanas sin agua y sin comida. Okay, Rosie? Okay? You're gonna be really happy here. De tortura de sexual de Señor Walsh. Well, Mrs. Walsh, I speak perfect Spanish, and I would be glad to communicate with Rosalita. ¿Y cómo esto en francés? Sí. Oui. Oui. Parlez anglais, s'il vous plaît. À tous des idiots. Le camp final. 3, 2, 1, décollage. That's all the French you need to know. Merci. Merci. Décollage! Today here in Europe, there were 40-knot crosswinds at 800 feet, dropping to 15 in the last 300 feet. Imagine that. 40 to 15 with a 500-foot change. Mamma mia. Do you have something more Mexican like El Camino? El Carro? El Camino? Isn't Camino road in Spanish? All right, let's get going. Hello. All right, so the thrust structure. We still got to figure out how this whole thing is supposed to disconnect. I am El Nino. El Nino is Spanish for the Nino. Damn, I missed the Vulcan launch. Shame on you. Oh, well. I had this teed up just for you, man. I wanted to do it this way.
8, 7, 6, 5, 4, 3. We have ignition. And liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight to the moon and beyond.
Whew.
Two good SRBs, hitting peak pressure on the SRBs.
Who is part of the United Launch Alliance since it is an alliance? It's a joint venture company between Lockheed and Boeing, Zombie. Without you screaming, it's just not the same. Actually, when I covered the Vulcan launch live, I freaked out.
8.
The reason why I freaked out, okay, you just saw it launch. It's like, okay, that looks good. Watch this thing slew off the pad. Now, we think Vulcan did some kind of pad avoidance maneuver, but essentially the rocket separates and goes that way. And it scared the crap out of me. I'm like, oh no, it's Astra. Watch the whole stack. I guess it was supposed to do that, but I didn't know that. And I went, no. Here. For those who are wondering what I'm talking about, I'll pause it at the right time and you'll see what I mean. Look at that. So, the launcher that says ULA, the backside of it is perfectly straight. That's perfectly straight up. Look at the tilt. The thing's doing this. Scared the crap out of me, dude. I'm like, please don't fly into the ground. That was the thought. I'm like, uh-oh. But that was supposed to happen. What it did was, a lot of rockets do like a pad avoidance maneuver. They'll give it a little bit of pitch right off the bat to get the rocket exhausts away from the umbilicals. That's basically so you don't fry the this thing that says ULA on it on the side. Please don't pull a proton. Yeah, dude, I was like, well, that's bad. Yeah, see how they got the rocket engines away from this tower piece, that gray thing? That's what they were doing. It's pad avoidance. Antares does the same thing. I do have a question. Was the tilt off the pad an intentional avoidance maneuver? Yes. And if so, did it overdo it because it looked quite steep from some angles? No. Yeah, there you go. Right from the man himself, Erudite. There you go. You just got to ask. Yeah, it's a pad avoidance maneuver. They did it to... So these things, when they chooch, they don't destroy the freaking left side of the pad. That's freaking sick. And here, for all the chooch, Vulcan streaming in chat. So this is Derek. Derek took this picture. Took this video. Check this one out. Headphone users, you might want a little... Headphone users, one more time. Headphone users. Got 5 seconds. This gets loud. Oh. I did, Foz, yeah. Yeah, I saw Trevor's footage. I like Vulcans, though. Master Louis? Yeah, whatever, 14 or something. Before NASA pulled the Vulcan footage, it's underexposed enough you could see the B-Force gimbal just before liftoff at the tilt. Cool, cool. You could hear the water clouds dampen the sound there. Yep. It's a lovely looking rocket, but those matchstick SRBs look tiny. Adam, you know what the messed up part of it is? Those SRBs are big. The only SRBs that we have over here that are bigger than those are probably like the SLS SRBs. Yeah, those GM63XLs are huge. Yeah, sure, Natch, I got you. What do they use to make the stream of sparks that lights the engine? Those things? ULA calls them radial outward firing igniters, or ROFIs for short. It's a Roman candle. It's a Roman candle. Yeah. It's a cool space version of a sparkler firework, but it's a Roman candle. It's a Roman candle. Aerospace grade sparkler. Yep, basically. Yeah, pretty much. Yeah, it's pretty much it. Louis, we can see you. Nerd. What's up, man? Send it. Whoosh.
Mission
That's freaking kick ass, man.
and liftoff of the first United Launch Alliance Vulcan rocket, launching a new era in spaceflight to the moon and beyond.
I was thinking a rotor on metal or something. No, it's just the aerospace grade Roman candle. The interesting thing is that ROFIs, those things aren't even called ROFIs in aerospace. That's like ULA kind of adopted that name. They're not even an outward. They're not like. You know how like every copy machine is called a Xerox machine? Like there's slang terms for things. Like limited slip differential is called positraction. Positraction is Chevy. That's what Chevy called the limited slip differential. I think Ford is like True Track or something. And then Mopar is like Shore Grip or something stupid. It's posi. I'm saying that as a Ford guy. It's positraction. Okay, you call it posi, right? You don't call it anything else. You don't call it Sure Grip. If you call it Sure Grip, people are going to look at you weird, right? ROFIs kind of are the same thing. They're not actually a radial outward firing igniter by definition. The original name for a ROFI is the starting mechanism, a torch igniter that's on the RS-68, which is Delta IV's main engines. The RS-68s have a radial outward firing igniter for their... It's actually not a torch igniter. It's a spark igniter. That's where the term ROFI came from. One day, some dude in Delta Mission Control or something just started calling these ROFIs because they are technically an outward a radial firing igniter, but that's not a ROFI. It's just a sparkler. It's a sparkler firework. It's just an aerospace grade of a sparkler firework. So they're called ROFIs. Everybody calls them ROFIs. They're not ROFIs. That's not what they're called. True trash. I mean, dude, I don't even call it that, man. I'm a Ford guy. I'm a Ford guy as best as it come. I don't even call it that. I call it posi. Frick whatever they call it. I don't care what they called it. It's positraction. I don't even know what it's called, dude. It sucks. That's not even, like, dude, you get a Ford 9-inch with posi, all right? It's not called that. It's true trash or true track or something. I don't even call it that, man. 9-inch with posi, all right? That's what it's called. I don't care what anybody says. True trash. That's pretty funny, dude. Frick that. That's not called that at all. Hey, Loopy. There you go. You got pictures? Cool. All right. I've placed like 6 parts for this Vulcan build. We really need to get this done. Nice. Okay. Nice a picture. Nice a picture. Very nice. All right. Let's get her done. Let's get the tunage. All right. So we've agreed to a 3.7 core size. Now, we got to do the inner stage, and I have to do the common bulkhead, or at least model a spacer for the common bulkhead to get the proportions right. Hey, Meg, I said this would take a while, so, all right, bear with me. You may have actually taken more parts away than you've added. Shut up. Are you going to simulate the rocket being fairly complete, but the engine's being delayed? No. Yes. Shut up. My engines, Jeff, are right there. Okay, where are my engines, Jeff? I'm thinking about where I got hung up here before we were talking about NASA and stuff. Where I got hung up is the back end of this thing. I want to design mine for smart reuse so we can dump the engines. I want to design it for that, right? I think that would be really cool. But also, where the heck does this thing detach? And how does it detach? We have a thrust structure right here. That's what this white loop is. That's a thrust structure. That also has the hold down points and stuff. And then right there, you have the aft tank skirt right there. So this ridged area is a structural cylinder that connects the side of the fuel tank before the fuel tank kind of goes hemispherical to the thrust structure. It's basically carrying the axial load here. Axial load is just the long axis of the vehicle. Yeah, if it's the bolts I identified earlier, dude, I don't know how, like, if this is the piece that detaches, where's the heat shield going? The downcomers are in the way. See the plumbing? The plumbing's right in the way. See what I'm saying? Like, I mean, I still will say that it looks like this thing detaches, this gray area. It looks like that's the part that it's pumping out, right? Yeah. Yeah, it kind of doglegged a little bit, Loopy. They had a 90, what was it? The flight azimuth wasn't directly 90. So it kind of went out and then it turned a little bit. Is it though? I'm not sure how I'm going to make that thing. I want to do the smart reuse version. Yeah, exactly. This version right here. But I'm just not exactly sure how that's going to happen. I would need to look at more pictures of this thing. Yeah, Adam. We have, so Natch was telling me up in the Northeast, it's, what is it? Winds 120 at 10, gusts up to 40. Yeah, that's near the ground. It's windy. It's windy and raining up here. But the good thing is the rain's melting all the snow. 6 SRBs, let's freaking go. He's got to be in that cavity that you can see. Yeah, but how would that mount? How would that mount? The plumbing is in the way, dude. See the plumbing right there? Really sad it didn't make it to the moon. They'll get it next time. I'm not worried. This photo is the non-smart version, right? Maybe some of the hardware is common to the Jettison version, but some other parts might be different. The plumbing goes around the middle area. It jukes. There's another picture. Okay, so that one's going into the bottom of... This thing goes in the bottom of that turbo shaft right there. Well, not turbo shaft, but the turbo pump. Huh. It does. Yeah, it splits, but I'm the locks line, the locks downcomers are there. This one goes up. This one elbows this way and goes down, and that one elbows this way and goes down. Because I know the engines are mounted 180 degrees off from each other. So locks is right there. It goes that way. And then this one must go out that way. So where did the methane downcomers go? Like, I'm not sure. Where's the methane pickup? Huh. I'm trying to trace the plumbing so I can figure this out. Add time? Oh yeah, I had to roll for that before. Alright. What's your add time? Ah, I rolled a 10. Hey, you rolled a 5. No add time for you. I'm wondering what this thing is right here. What's that thing? In this design. It's not pipes. Those might be ullage tanks. Ah, the ullage tanks are in there. Okay. Did you get that add time before? Oh, that's John's picture. Alright, let's roll. 15. This is the one from Predominant. Rolled 2. No ads for you. That sucks. Alright. So, let's set our diameter first. So, here's what we'll do. Separate all this. And, you know, I said we'd work on some pretty nice building techniques in Kerbal 1. Here they are. So, like, Cake, I know if you're here, you asked about them a little while ago. I don't know if you're still here, buddy, but... So check this out. See, I'm placing a strut, and I have absolute snap on. I'm going to absolute snap the strut to these two pieces. Now, basically what I have here is a ruler. I can use it to get a alignment. I basically made a ruler in Kerbal. So I attached it to this piece, which is just going to be my basically ruler holder part. The amazing golf ball whacker part guy. So let's make sure we're lined up with the axis here. We're lined up with the long axis of the vehicle in the center, like that. Right? And then set that right at the outer edge of the tank. Now the reason why I'm going to do this, one is, you know, it's good to get measurement, right? Good to get some measurements. But this will help me when I go to do this. So take this off for a second. Now we have our size. Give me a 1.8 meter fairing like this. All right. And this is the reason why I like to get lengths and stuff. So you can take these parts on the vehicle and just attach them over there and then just gizmo them out of the way. We don't need those for a second, right? Now let's see if we can find Vulcan's inner stage and the length of the inner stage. Right? That'd be a good place to start. So just we have our width that we need. And let's see if we can look up at Vulcan's interstage. How tall is it, give or take? So 5, 10, 15, 20. It's a, let's, 5, 10, 15, 20. It's, give or take, I don't know, maybe 18 feet length or something. So let's take 18 feet because ULA has feet here. So 18 feet. Divide that by 3.3. That gives us 5.4, a 5.4 meter, which, yeah, that's more or less right. 5.45 meter interstage length. Now, times that by the running scale that we're using 6.9. That gives us a 3.76 meter length interstage. All right, cool. Now let's measure. Go here, go into our Kerbal Engineer report, and check our vehicle length. Separate this for a second. It says the length is about 16, right? Take the fairing, shut the fairing off. Don't stage that. Right, shut that off. Okay, so we need to measure 3.7. What's a good way to do that? Well, the fuel tanks that are 3.7, those are 3.7. That's fine. We can use these. So take one of these, put this off to the side, right? That's the length of our interstage. So what do? Move the fairing out of the way here for a moment. Grab the ruler and make another ruler. That one attached to the fairing though, because I copied it. So take that, make sure that's absolute snap, make sure that's absolute snap, right? And then move this close like this, copy this piece, and just put another ruler down there so we can have one to copy. Now take this thing, right? Take this ruler. Where do we want our interstage to start? Let's say our interstage starts right here. Let's say it starts at the front of the I-beam for the most part, okay? Jeez. All right. Now, we're going to need two rulers here that go sideways, right? So flip this sucker on its side, like that, and then flip it 90 degrees this way, okay? Now take this, move this down here into the center, and then go this way with it. Go this way with it, and mark the top of where you want your interstage to be. That's not exact, it's very close. Yeah, it's close enough. All right, so take this, right? Stretch it across, right? And then, you know, we should be able to take this exact one, right? And now set this to absolute snap. The absolute was close enough to the length that we need, so that's why I kind of just kept it. I didn't bother doing a fine adjustment, right? So go in here like this, set it so they're clipping into each other, and then move it down here. And that one seems like it's staggered pretty much the exact same. So I know, because we're using the tank as a guide, that one's a little bit too long, that one's a little bit clipping, right? I know that we have 3.7 meters here. There's a 3.7 meter difference between the two lines. So now we get rid of that tank. Now what does that leave us? So we'll take the ruler that we copy and paste, put it over here like this. What does that leave us? That leaves us with a template to build our interstage. We're gonna build the interstage out of a fairing here, right? It's Kerbal scaled, man. Kerbal scaled. Yeah, Kerbal scale. I'm using 0.69 because of the scale of some parts, Vulcan. Yeah, so why do I make interstages out of fairings? Because I want my rocket engines to be occluded. Obviously. Yeah, no, that makes sense. Forgot. Yeah, all good, man. All good. Alright, so now we go into build fairing, right? Now we look from the top down. Do I need to say why this would be super useful with isometric views. If I could do precision movement in Kerbal 2 with isometric views, we could do stuff like this with the ISO views. Way easier. So place it. Were we exact? No, we weren't. Yeah, there we go. All right, so just left alt, left mouse, terminate it for now. Okay, so that's obviously not the length that we need, but I can gizmo this into position where we can get the end where we need, right? So now take the fairing again, edit, there's your interstage. 3.7 meter interstage. So that's the top of our core. Now, take the fuel tanks that we had. Attach that to the fairing. Now take the fuel tank and a gizmo and do that. There you go. Now you got an interstage. That ULA illustration is actually inaccurate and asymmetric, by the way. How could you have an asymmetric interstage? Oh, yeah, well, actually, yeah, probably. Mm-hmm. Does that look too long? Or is it just me? Check with I-beams. Well, I know it's 3.7, dude, but I'm... Vulcan, I'm going to use your footage here for a second. Use the YouTube stuff if you're gonna. Yeah. You said 5.8, right? 5.8 times 0.69 gives us... Let me check something. 0.62 gives us 3.5. Huh. Alright, Antari, see you, buddy. It's way too long. Either that or my tanks aren't right. I think I'll go and measure the tanks. I gotta get the length of the tankage for Vulcan. Basically, yeah, the length of the oxidizer and LNG tanks. With the reinforced CBH in there. Common bulkhead is what it stands for. The bottom of the liquid oxygen tank is the top of the liquid natural gas tank. EJ, how does the fifth ignition coil affect a 4-cylinder engine? That can't be correct, right? What kind of motor is it? What kind of motor is it? There should be no fifth. I don't know, Louis. I really have no idea, dude. There might be some motor out there that I don't know about that has a fifth, you know? Alright. We'll just eyeball it, I guess, again. So, 5, 10, 15, 20, 25, 30, 35, 40. Okay, so 40 feet divided by 3.3 gives us 12 meters times 0.69, 8.36. That's why it looks wrong. That was a 5-meter tank that I used as a template because I'm an idiot. Alright. Thanks, EJ. Very cool. Yeah. Alright, cool. I was getting real confused there. Oh, it was just Strimmer Man catching a case of the dumb. Don't worry. I was really confused. I'm like, I don't understand why this is doing this. Alright, that gives us the length that we're looking for. Edit that fairing. There we go. Yeah, that looks a lot better. Excellent. Cool. Get rid of that. Alright. Much better. Much better. Now, we need to simulate our bulkhead reinforcement here, right? So, each one of these tanks is about 3.7 meters long, as it's about the same, almost the same width as the same height, right? Give or take. So we said it was 40, right? And what was the size that we ended up getting, extrapolating from that? 8.3. So this is 3.7, 3.7. That's 7.4. And we need it to be about 8. Okay, cool. Take this, watch this. I want another fairing so I can replicate the common bulkhead and get my tank lengths to be right. 2 of these back to back, not exactly. It's close, but it's not exact. If I try to copy that fairing right now, it's not going to do anything. Here's a trick. Watch. It doesn't like copying that dang thing. So take this, merge it with himself. Merge it with itself. I told him to go merge craft file with himself. Now I have the fairing. Get rid of that. We don't need any of this. Detach these tanks for a moment. See? Now we have the tankage. Now we have the tankage. The tankage. Alright. So, that's 7.4. We're looking for 8.3. So we need to add basically another meter. So what's about 1 meter here for our common bulkhead? These are 1.2? So we move our absolute snap on 10 centimeter increments. So if we're right here, right, and I click this 1, 2, right? This is a 1.2 meter tank. Right? Now just take this fairing, right? Fairing expansion. Take the fairing. Gizmo it right there. Perfect. That gets us exactly what I want. But now this fairing is clipping a little bit. Guess what we're doing? Get the rulers out, bro. Mark basically where this tank needs to end. It needs to end right there. Right? So take this. I was going to say rotate that out of the way, but that doesn't matter. Okay, so take this tank, move it up here. And then take the ruler piece, move it up there, like that. That gets me the length that I need for the common bulkhead. Edit the fairing. We already have our diameter set. Terminate the fairing. Move the ruler back down on the center axis here so we know. So we have a length measurement. Go down here like this. Move that right into position. Now, gotta go through setting all this to grandparent part. Make sure we get some struttage in there. Now take the back tanks. Take that. Move that into position. There you go. Vulcan core stage. You have a spot to mount your SRBs. And now we need to work on the aft skirt of the tank here so we can mount our engine section. What are you using to measure? The strut rulers? The strut rulers are used for lining stuff up. I usually use I-beams, but in this particular case, because the interstage was 3.7 meters long scaled, I just scaled it. And what I need to do with this one right here is I need to add another one of these to the back for the aft skirt. That'll get us the correct tank length, if I'm looking at this right. So from basically the bottom of the inner tank here, so the aft skirt right there, or the bottom of the LNG tank, we have 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70, 75, 80, 85. 85 feet. Let's just call it 90 because that's where the top of the bulkhead is. Let's call it 90. I mean, we meet it in the middle. Let's say 87.5. So 87.5 feet divided by 3.3 meters gives us 26.5 meters total. That's the total size of the core stage, right? In real life. Now I times that by my scale, 0.69. Nice. That gives us an 18.29 long core stage. Now, let's go in here like this. Take this, move this forward. Move that all the way up here, like this. Get rid of the engines. What's our length? Our length is 20 right now. Length is 20. We know our length is 20.8, and we know that our inner tank here, or the inner stage, is 3.7 meters. So what's 20.8 minus 3.7? 17.1. Is 17.1 what we were looking for? It's not. 18.29. We need to add another 1.2 meters of tankage or something. So what do? Well, me personally, I know what I'm doing. We're gonna take this. We're gonna go 5, 10, 15, 20, 25, 30, 35, 40. Or no, it's 10 centimeter increments. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. We got to move it about a meter, give or take, right? Yeah, about a meter. Easy peasy. Cool. So if we just sit and look at that. Yeah, that looks about right. Excellent. So now you take this, move that back into position, and here's what we do. We lengthen the common bulkhead. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Trust me. Just so we can get this right and we can line it up, I'm going to move this one 10 centimeters forward. And now we take the fairing, we edit the fairing, and we make the fairing end right at the strut, right there. Now I move this backwards. And then, because I needed to make space so I could line up with the strut, we can move this one click forward, and it gets us the exact same overlap, there to there. See? Now, we might be able to take the fairing and adjust the sides. If we adjust the sides to 4, it gives us the same exterior edge flow. So now we don't have that overlap. Now you can't see it. Pretty cool, huh? How much knowledge of rocket ships is needed to play this game? Not much, Pigeon. You don't need to play like I do, dude. Don't do that. I have like 20,000 hours in this game. Don't play like this. Just put rocket parts together and figure it out. These are extremely advanced builds for a Kerbal player. This is like not a high school level intro to building in KSP. This is EJ with 20,000 hours of Kerbal experience building very precise stuff. I mean, it's precise for KSP, but you get the idea. There we go. We have our Vulcan interstage. We got our Vulcan tankage. Not bad. We probably could have gotten away with adding another 375 tank for our common bulkhead. I mean, that's just wasted space at this point. Let me just check. Well, we don't have payload up top. But guess what I'm going to do now? I'm going to take this piece. Right? Now, we might not have the proportions of our tank exactly correct. But what we do have is the overall length. That looks to be the right length. So what I'm going to do is I'm going to set another strut down here. This other strut, this ruler, basically marks the tank. That marks the tank length. Right? We technically don't need this, because if we want to screw around with this, we don't... I don't know. What scale is this? 0.69 scale. The reason why I'm using 6.9 scale instead of 6.2, which I usually use in Kerbal, Kerbal builds are usually volumetrically about 2/3 the scale of their real-life counterparts. Give or take. The reason why I'm using 6.9, first of all, because of the number. That's the meme number. Second of all, if you take Vulcan sizes 5.4 and you scale it by 0.69, it gets you 3.7 core diameter, which is one of the tanks that's already in KSP. If we used, I mean, don't get me wrong, guys, we could go regular tankage. We could go with a regular scale, 5.4. Times that by 0.62 would give us a 3.34 core stage diameter. What I would do at this point is I would use 2.5 meter tanks inside of the body of the vehicle and then make the entire outside of the vehicle a fairing. Yeah. And then I would put fuel tanks inside. We could do that too. This is a little bit easier. Science or career is the best way to learn. Yeah. That's not really the gist of what I was saying, RJ. I was saying, no matter what you're playing, don't play like me. Don't do this. Don't try to build like this. You're not going to. You're going to try to do what I'm doing, and you're just going to get confused. B, it's me. I have a lot of building time in this. You guys know already. Like, this is how I build. Find your own methods to build. Or just copy mine. I don't care. Doesn't bother me. The slight overscale is a good solution. The reason why I went with that scale too is because that means that the boosters are scaled correctly to our core stage. Because we have a 1.2 booster. This is a 1.25 core diameter for the kickback, which is what we're going to end up using. Right? 1.25 scale like that. If we go to the gem, right? 1.6 diameter, right? 1.6 diameter times 0.69 gets us more or less exactly the size that we're looking for. More or less. It's not going to be exact, but that's what you get when you use stock parts. Simultaneously, 22 meters times 0.69 scale, 15 meter long thing. These are like 14 meters long. With the nose cone, they're pretty much 15 meters. So, like, when we do go to place SRBs, they're going to be like this. And if we go look at a side view of Vulcan, like, the points on the nose cones go up past the CBH. So, let's just say right around there. Common bulkhead should be right around there. Those nose cones are a little short. Something like that. No, that looks like poop. Maybe we should just go with those nose cones. Yeah, please forgive the crudity of this model. I didn't have time to build it to scale or to paint it. And this should more or less give us pretty much the position where these need to be. Yeah, that's pretty much right. If you make them more round, the fairing will look fine. Yeah. Vulcan's a pretty big rocket, dude. Yeah. Just on a side note, just a side observation. Okay, cool. Let's get rid of that. Now, once again, I need a copy of this so I can make the aft skirt. We need to be able to make this white part right here. So this is the stage aft skirt, and that's the thrust structure. We need to be able to make these pieces right here. And we could just use a copy of our CBH piece and a copy of the inner stage, right? We could use that down there. Good way to do that is to take the vehicle and merge it with itself. I told him to go merge craft file with himself. Now just get rid of that. Shift left click will take the piece off. Get rid of this. Take this piece. Attach it here. And that's obviously too long. Right, but with some modification, we take fairing. We make it the right size. How the hell is this gonna work now? Okay. All right. Well, this is good progress for sure. But I mean, if I'm just going to make the thrust structure, this should be pretty easy to do. However, that's not exactly what we're doing. How did you close the fairing there? Left Alt plus left mouse button, will stop a fairing. It'll basically end it for you. Have you ever built the Eagle lunar module in KSP before? The Lemtal? Yeah, many times. Oh yeah, there's parts that came with the Making History expansion for KSP that give you basically all the parts that you need. Sure. I even built it with a rover. With the robotic parts that are in KSP 1, and then that and the rover wheels. Right? See the no, not those ones. These ones right here. See the wheels? I built the rover and I made the rover fold off the side of the Lem and pop out just like the real one. Yeah. I made a scaled replica of the descent module and the ascent module for a career mode save a long time ago. I don't have those files loaded into this save, but they're around. So that piece right there is about 5 meters. Or not 5 meters, it's 5 feet. So 5 divided by 3.3 gives us 1.51 meters times 0.69 gives us it's 1 meter long. Yeah, that's actually right. That's 1 meter, give or take. 1.2 meter is the diameter on this tank. Right there. And if I put that on the side, that should just be clipping a little bit out the back. Yep, that's perfect. So this piece right here is representing those two right there. The thrust structure and the aft skirt. Now we got to work on the bow tail piece. But there's something I'm thinking about here. The Saturn V is on Kerbal X? Oh, cool. Neat. What did you use for a Lem counterbalance since the rover is on one side? I don't remember. The science experiments. I had a container loaded up with experiments on the other side. These actually are mass when you load them in. Yeah, that's what it was. Yeah, I had all the experiments loaded. An ALSEP package and 2 SEQ storage units. Because if you put this on here and then you put an experiment in there, it adds mass. Because it's mass. That's what I weighed one side down with ALSEP experiments. Apollo Lunar Surface Experiments package. That's what these things are supposed to be based off of, including the NUC PD. Yep. They actually brought a little mini RTG out to the moon. Yeah. Placed it out there for testing out power generation on the surface. Radioisotope thermoelectric generator. Yep. That actually was the thing. Hey, Kuro. What's going on, buddy? minimized Starbase Live by accident. There we go. Can you try the 3.75 meter reaction wheel to simulate the black part of the piece? There's no 375 reaction wheel, Adam. There's only 2.5 meter. I could take the fairing and color the fairing. Nah, that's not going to do what I want. I think there's a 375 in Kerbal 2. I think. How does the CSM unattach from the lunar module to flip and dock? Is it attached to the engine or the fairing? On the real one? So here. Okay. 7, you're asking on the real thing, right? Like on the actual Saturn V? All right, here. So this is an S4B. It's an S4. If you want to be really specific, it's an S4B-500. There's two different types of S4Bs were made. 3 different types of S4 if you want to be technical. There was the S4 base, and then there's the S4B. The S4B has 2 variants, 200 and 500. The S4B-200 is the Saturn 1B's upper stage. The S4B-500 is the Saturn V's upper stage. What's the difference? Ullage motors, a couple of things here and there, not much. Now, take a look. So you see right here, you have a little bit of a cone, right? There's a conic piece right there. Now look at the attachment points on the conic piece. Okay, you have 1, 2, 3, and 4, right? At 12, 3, 6, and 9. But if you look real carefully, there's another thing here. There's these things. See those right there? 1, 2, 3, and 4. Well, therein lies the key. How the heck does the Saturn V fly into space with the CSM, which weighs 52,000 pounds, 2,500 kilos, or 25,000 kilos? How the heck does that thing fly into space sitting on top of the LEM? Isn't the LEM supposed to be really, really delicate? And the answer is yes. So, is the CSM's motor in line? Is it sitting on the ascent module? Well, no. The ascent module is not very, very heavy for what it is. It's the pressure vessel on the LEM, we could punch a hole in it with a screwdriver. It's very, very light. Obviously, you can't use that as structure. So, remember, I told you about those attachment pins on the S4B, right? So let's back up a little bit. Let's click on the wiki page for the S4B, right? S4B, right there. See that? What was the S4A? Saturn 1's upper stage, question. It's just called S4. Right, so check this out. This is from Apollo 7. Apollo 7 launched on a Saturn 1B out of Complex 34. So that's an S4B-200. Why am I pointing out the differences to you? Well, there are differences with the ullage motors, right? So the separator motors on the S4 on the Saturn V has 2 ullage motors. The one in the Saturn 1B has 3. But one of the components that's pretty much exactly the same is the thing that I'm showing you here. So take a look. Remember I told you there's 8 different points of attachment here. And then there's this cone piece, right? So the ones that I pointed out first, these ones right here, actually those are the ones that I pointed out second. Those ones right there, right, are basically a pivot. The S4B conic adapter is a structural piece. See these pieces right here? So that cone, the cone piece, that cone piece is a structural thing that has pedals on it, right? When those 4 pedals are together and it's in a conic shape, That's what's holding up the CSM. 7. Hey, Just Ank, 16 months. See the pedals? See those? This is like a fairing, basically. It's a fairing that works like an interstage initially. So when the Saturn V's riding up into space, and when it gets up into space, you have your CSM, right? You have your module. You have the Apollo command module, right? And then you have the service module behind it. Service module is the structural piece. The bottom of the service module here is attached to the stage adapter here. That's what it's called. It's called the stage adapter, right? Because it's not an interstage, right? But it's not a skirt either. It's an adapter that goes from the S4B tank diameter to the service module diameter, right? So that's holding up the CSM. And the CSM's nozzle is kind of hanging in there. The nozzle on the service module. It's just hanging out. It's hanging out, kind of dangling above the LEM. And the LEM is attached to the bottom of this pedal adapter. Now, here's the kicker, right? Here's the kicker. So what is the LEM sitting on? Is there a payload attachment fitting on the top of the S4 that's kind of holding the descent module? No. Why would you put a PAF in there? That's a waste of mass. So you want to see something real trick? You want to know how smart the Apollo program is? Let's look at a LEM for a second. Apollo. Let's look at the LEM. All right. Pretty cool. One of the most fantastic pieces of equipment humanity has ever devised. An entirely purpose-driven design here. So, let's take a look. Where do you think this thing hooks in? Where do you think it hooks into the Saturn V? Down here? Maybe the Milo wrap, right? Maybe this part. Maybe the part that says United States, this structural piece on the descent module? 7, I'll give you a hint. What's holding up the LEM right now in this picture? What's holding up the LEM? This is not a I'll use that in a second. Yeah, that's a good picture. What's holding the LEM up off the ground? Why isn't the descent module digging into the dirt, or the descent module, the LMDE, Lunar Module Descent Engine? Why isn't that digging into the dirt? What's holding it up? This is really simple. This is not a trick question. The lunar surface is holding it up. Squishchin, this is why I ignore you. Now go into the corner. The lack of gravity is holding it up. The landing legs are holding it up. There's the key. Take a look. Let's look at these landing legs. Let's look a little bit closer. Well, the landing legs deploy, right? They fold out, right? But there's a part right here that's triangulated on each leg, right? See these struts? That part doesn't move. So, this is the picture that you linked up that I want to show. 7, take a look at this. The landing legs fold, right? They fold up. So obviously it's not going to be held up on this part of the LEM. No way. Right? They're folded. And they're only designed to hold up the LEM on the lunar surface, right? Now, obviously, it's not attached to the nozzle. The LMDE is too delicate. So how do you attach this thing? Scroll down. I got this, man. I got it. How do you hold this up? How do you hold up the LEM? Can't dangle it by the ascent module. It's much too delicate. Can't use the lunar legs. The landing legs are designed to hold it up in lunar gravity. What are the legs attached to? They're attached to that triangulated strut piece. See that? Guess what? That's strong enough to hold something up. Let's scroll down. Yeah, go. So remember how I told you on the S4? Remember how I told you on the S4 that it has like 8 points of attachment in this picture? Or not that, this pic, no, not that one either. This picture. The LEM is not held up by the landing legs. It's hanging inside of this S4B stage adapter. See this piece right here? That X? That's where the LEM attaches. It attaches on the sides. The descent module is actually hanging inside of the stage adapter. It's hanging from the struts. And those struts are also the landing legs. They're part of the landing mechanism. If that piece is strong enough to be held inside of a Saturn V, it's definitely strong enough to hold up the landing leg, because on the moon you have 1/6 the gravity, right? See right there? Right there, on the edge of the LEM, there's a little tiny attachment piece. Little tiny bolt hole right there. Right there. And right there. See there's a little nubbin sticking out right there? That's where it bolts to the S4. It's hanging inside of it. Actually, the ascent module is being propped up, right? The descent module is hanging. This is a primitive form in rocketry of what's called a load reaction. Basically, if you hang a payload inside of a payload fairing, or a stage, for instance, you're hanging it inside of there, it doesn't have to be structural. You know why? Because when this thing fires off, 7.5 million pounds of thrust come out the bottom. That's a lot of force pushing up, right? You can take... So if you had the LEM just stacked with the CSM on top of it, right? The LEM would have to be strong enough to not get sandwiched between the CSM and the S4B, right? So, what do? Make a load reactor. Take it out of the equation. The LEM doesn't need to be strong enough to be able to stand up down here, because it's designed to land on the moon. You can save mass that way. So just hang it inside of it. Easy peasy. Hang it. And attach the landing legs to the hanger piece. Because if the hanger piece, right, is strong enough to hold it up inside of the S4B in Earth's gravity, and the landing legs are attached to that, you know that structure is going to be strong enough to hold it up on the moon. Yeah, that's a good picture, Aqualex. You can't really tell, though. But see, right here? That's where the LEM attaches to. It attaches on the rim of this cone piece. When the CSM separates, the petals open up and they separate. They fly off. They're in early versions of the S4B, like on the S4B 200, the petals actually opened up. But the Apollo engineers said, why the heck do these things open up and close again? That's the stupidest thing. Why would you do that? Just have them separate. It's not like we're going to use them again. It's not a payload bay, right? So in the later versions of the S4B-500, those petals just open up and just fall off the sides, right? Now here, right there, that's where the LEM is attached. This X piece is a boilerplate. You know why it's a boilerplate? Because on the Apollo 7 mission, look, if you notice there's a targeting reticle there. On the Apollo 7 mission, they separated, turned the capsule around, and tested the maneuvers to pluck the LEM off of the S4B. Apollo 7, low Earth orbit mission, might I add. See the targeting reticle? That's what that is. There's basically a crosshair on the window of the Apollo capsule, and the command module pilot would line up the crosshair and dock those. Well, it wouldn't dock. There's nothing to dock to. There's no LEM here, right? But yeah, there's a little bit of a better picture. But if the LEM is docked to it, look, same targeting reticle. Weird, huh? And then there's your probe and drogue. And the legs are holding it in place. 1, 2, 3. There you go. So the LEM 7 is actually partially hanging inside of the S4B. And the CSM is sitting on a stage adapter. And the stage adapter cuts away, and that's what gets exposed. So the CSM separates, when it separates, the petals pop off. It turns around, attaches to the lem, and then plucks the lem off of the S4B. Was the Apollo 8 through 10's LEMs operational? Trick question, Victory. Apollo 8 didn't have a LEM. Nope. There was nothing in here on Apollo 8. They put nothing in the stage adapter. It looked very much like that. Yep. Apollo 9's? Yes, fully operational. Apollo 9 had a fully operational LEM and a fully operational CSM on a Saturn V, and it never went to the moon. You know why? You know why? This is really topical. You guys are going to love this part. You know why they did that? Because they needed to test an integrated system. They needed to make sure that the capsule and the lander, all the systems on all of those things work just fine. And they did it in low Earth orbit on Apollo 9. Jeez, that's weird. Gee, how topical. Yep, see? There you go. It's held up by this strut pieces right here. See? SLA adapter. There you go. And then, during Apollo 10, 10's lander was 100% operational. Victory. It was 100% operational. They didn't load it with enough fuel on purpose. It did not have enough fuel to go down and land. The LEM only had enough fuel to separate and rendezvous back with the CSM. What Apollo 10 did is went out to the moon. They did a full, basically they did everything that Apollo 11 would do later. This was the test for it. They separated the LEM from the CSM and did everything up to powered descent, to PDI. Powered descent initiation. They did everything up until that. PDI is the landing burn. That's what it's called. That's what it was called for the Apollo program. Apollo 10 did everything up to PDI. Apollo 11 did the exact same thing. It was a mirror image of the Apollo 10 mission. The only thing is that the LEM descent engines had full tanks of gas. That's all. I meant operable rather than operational. Yeah. They were all real. Victory, for every test, they made a real CSM and a real LEM for every test that involved either one of those vehicles. Yep. What happened to the Apollo 10 LEM?
No throttle up.
Is that the one that's... Yeah. Yeah, Snoopy. What happened? No idea. Nobody knows where it is. Yep. KSP 2 keeps launching on my second monitor. Got any ideas for a fix? I don't know, Bly. The S4B-200 you showed reminds me of neutron reclosing fairing design. Design is cyclical. Yeah, I don't really know where that thing ended up. So here's what they did during Apollo 10. They got up to PDI, right? They descended down to a low orbit, and when they got to PDI, all they did was jettison the descent module. So the descent module crashed onto the surface. And then the ascent module came back up, rendezvoused. The crew got out of the LEM, went back into the CSM, they jettisoned it, and then they remotely commanded the ascent module, which basically had a full tank of gas, to fire until depletion. Nobody's seen it since. We have no idea where it is. Yep, no idea. Why was the landing leg folded in a claw instead of straight down? Why was it folded like that? So it could fit inside of there. It's so it could fit inside of the stage. Yeah, see? That make more sense? Tessa, I don't think it's around the moon. I'm pretty sure it's heliocentric. Yeah, nobody's seen Snoopy since. That was the name of that. That was the name of the Apollo 10 ascent module, Snoopy. Nobody's seen it since. We don't know where it is. It could have. I mean, it may. Tessa, if it didn't escape the moon's gravity, the moon pulled it in and it crashed onto the surface. Contrary to like what Kerbal teaches you, the moon, you can have decaying orbits on the moon. Lunar orbits decay naturally in real life, not in Kerbal. Now I know what people are going to say. How does that happen? How does that even happen? There's no atmosphere on the moon. Yeah, you're right. There is non-uniform gravity though. Precession. Lunar gravitational precession will pull you in. Yeah, there's decaying orbits on the moon. So if Snoopy didn't escape the moon's gravity, if it didn't escape the moon's gravity, it's crashed onto the surface. If it did escape the moon's gravity, it is in solar orbit somewhere. Yep. Yeah, that's the only flight-proven LEM. Yeah, we don't know where it is. Maybe someday we could go find it. No possibility to escape the moon's gravity, but not Earth? Well, MK, it really depends on the ejection angle. If it did reach lunar escape velocity, depending on the ejection angle, it might either Earth pulled it in, it's in a high Earth orbit, in which case, if it was in an orbit similar to the moon, when the moon came around next time, it would shoot it off into solar orbit, or it would crash into it. How does radiation exist in space? What do you mean, how does radiation exist in space? I don't understand the question, Smoke. How does it exist? Well, it can exist in a vacuum just fine. How does it exist down here? In 2019, someone might have found it, but I can't find a follow-up. NASA says heliocentric. I think heliocentric, but yeah. Believe it or not, yeah, that's the only flight-proven ascent module still around. Every other ascent module burned up in Earth's atmosphere when they came back. Yep. Or they left it around the moon. Actually, yeah, I don't know if they all crashed into the surface of the moon eventually because of precession and stuff. But anyway, 7, great question, dude. That was a really good one. It's trick, man. Apollo's really, really smart. And boy, dude, did they make that look easy. Look at how much difficulty Artemis is having right now. And then look at just the Apollo program. Dude, the U.S. just crapped this out in less than a decade. You've got to be kidding me. That's insane. You should check on the pilot in the far left monitor. They seem to be excited about something. She's fine. She does this all the time. Yeah, they crashed S4s in Apollo ascent modules to do seismic tests on the moon. That's right. Also, nice shot of the Cape back there. You know what? Let me look at something real quick. Let's take a peek. So this is a shot from Apollo 7, right? ASO 7, Apollo Saturn 7 right there. You know what's super interesting to me? 39A is under construction in this picture. So is 39B. Because Apollo 7 launched from Complex 34, which is right there. And look, the ITL causeway doesn't even exist. Whoa. That's weird. Yeah, no, Complex 34 is right there. Yeah, the ITL Causeway isn't there in this picture. Port Canaveral is. Port Canaveral's there. That's cool. But look, it's not even finished yet. Dude. Cool. There's like a gigantic launch complex right here in this, like, nowadays. And then obviously 39 is still there. Could we do Apollo application? Yeah, the Apollo applications program, Doom, is what you're talking about. Could I do it? I've done that many times in KSP. Oh yeah, built out the Saturn V architecture. Oh yeah, done that. Yeah, I've done that many times. Profit motive versus national pride motive. Yeah, fatal. Yeah. You know a lot about me. Yeah, Apollo. Yeah, exactly. What are we talking about now? Is it raining? Yeah, you're hearing rain, Pigeon. It is raining and it is windy. If you can hear it, that means it's pretty bad. I've seen your Saturn V building KSP. I was wondering about doing missions past the Apollo architecture. I know, Doom. I know what you asked. Yeah, I've built it out many times. Yeah, done all kinds of cool stuff. I just saw the news. What the frick, NASA? Yeah. Sparks, I was pretty mad today, dude. Pretty mad. I got pretty heated. What news? Artemis.
Discovery, go at throttle up.
Artemis 2 got delayed. 12-month slip. Artemis 2 got delayed by a year. Artemis 3 got delayed by a year. And Artemis 4 got delayed by 2 years today. Artemis 2 is now net September 2025. Artemis 3 is September of 2026. Artemis 4, sometime in 2028. Not even a concrete date. Oh, nice, God. That's cool. What happened? Oh, man. It's not HLS, Apollo. SpaceX said in the meeting that they'll be confident that they're gonna deliver the lander on time. It's a multitude of things. It's a multitude of things. The short list would be. Was there a press conference? Where's the link? There was. It's floating around, dude. Press conference is about an hour. Long story short, Apollo, they found a failure mode in Orion's heat shield from the Artemis 1 mission. And well, NASA is adamant that, you know, if people were on board Artemis 1, the heat shield would have been fine. They still insist that this behavior needs to be more well understood. Meaning that the heat shield charring off in certain areas is a problem that could get somebody killed. That's basically what I surmise from that. I think that's fair. A fair assessment. So the heat shield could possibly not be adequate for lunar orbit, for trans-Earth injection reentry, meaning coming back from the moon. So the heat shield basically, yeah, Artemis 1 was supposed to be the qualification for that thing, and it failed. Yeah. It charred off in a way that they didn't understand, which is interesting because, you're not... Artemis 1 with the waterfall style testing means you're not really supposed to find any surprises when you go to do the test flight, but that's okay. It broke off, Adam. A piece of it broke off. Chunks of it were missing. Chunks of it came off during descent, during the lunar entry interface. The other things that they were running into is a power consumption problem during potential Orion abort scenarios. Basically, if an abort is triggered on Orion, the batteries cannot handle the load of the power consumption requirements of an abort contingency that could potentially cause a loss of control. They can't take the shock load of an abort. So that's good. So the batteries, which were pretty adequate during the Orion flight, during the Artemis 1 flight, but Artemis 1 didn't fly with a launch abort system, right? Has a potential where it could cause in an abort, you basically pull too much power out of the batteries and it can cause a loss of control. It can cause an LOC during an abort. So, yeah. Oops. And then the third big thing. Yeah, Fatal, if you just get link perms from a mod, link it up, I'll show you. The third one was that the motor control valves on the Orion life support systems, they passed acceptance testing for Artemis 2, but failed acceptance testing for Artemis 3. Rain. Victory, after a year of analysis, I'm pretty sure they could rule out squids breaking the capsule during recovery operations. The motor control valves for their life support systems, which did not fly on Artemis 1, have problems with the motor control valves for the CO2 scrubbers for the life support systems. Basically, a supplier made a bunch of them. They tested them for Artemis 2. Acceptance testing, they had acceptance testing for Artemis 2. What is acceptance testing? So, say you're building a car, right? And you're going to put an engine in, right? To be absolutely sure that engine works, you need an acceptance testing. So put it on an engine dyno. Make sure that the engine works. And then, if you put this motor in a car, it's going to work because you tested it already. That's what acceptance testing is. The life support system motor control valves for the CO2 scrubber, or the motor control valves for the CO2 scrubber for Orion's life support systems failed acceptance testing for Artemis 3, but passed for Artemis 2. Are they different? Did you change something? Is it a quality assurance issue? Why did you change something? Or did you change the acceptance testing? Why is the acceptance testing different? Why would the life support systems from Artemis 2 and Artemis 3 be different? Long story short, guys, a lot of red flags. A lot of red flags for me. That's not good. Yeah. And then, yeah, that was the gist of it. And then the rest of it was NASA bureaucrats circle jerking about how safety is their priority. Well, okay. Now, don't get me wrong. You're going to run into problems. You're going to learn new things by flying. That happens. It happens. You're always going to learn something new, even from a successful mission. You're not supposed to learn something new from a waterfall style test. Yeah, you're not supposed to learn something new. Like a good example would be Tori Bruno the other day with Vulcan when they went to launch it. They didn't learn anything new about Vulcan. It did exactly as it was supposed to do. That's good flight testing. That's how you waterfall test. Did we see anything with Vulcan? You know, Vulcan kind of seemed like it came out of nowhere, didn't it? ULA did sufficient testing and found failure modes. All the failure modes that they found on the ground because their testing was comprehensive enough. For instance, high axial load scenarios for certain mission trajectories for the Centaur 5 can cause a leak and cause a catastrophic structural failure, basically cause the balloon tank to pop. They caught that in testing. They remedied the problem, and that maybe delayed Vulcan by a couple of months. That's how you do waterfall testing. I'll be honest with you, dudes. I understand you learn something. You should learn something every flight. You should not be learning from testing or from an integrated test like that. You shouldn't have these type of failure modes. They should not be popping up in this type of testing. I'm sorry. They shouldn't. They shouldn't. Waterfall testing means that the new things you should learn would be that your predictions are spot on, right? That's another way to say that. Yep, pretty much. Yep. Big red flags. Not just, dude, like Orion's environmental control and life support systems. Now, with the Eclipse, it's good to run into problems here because the Eclipse hasn't flown yet. The life support hasn't flown. Artemis 1 didn't fly with a life support system. But I have an honest question. If it did fly with a life support system, would you have caught this problem? Food for thought. They didn't put a life support system on Artemis 1 because there's no people aboard. No need to put people aboard if there's no need for a life support system if there's no people aboard. SLS has this whole testing regime where they kind of add in components over time. And I'll be 100% honest with you. I've been thinking about this for years. I hate it. Yeah, that's the long story short. I hate it. That's a really weird way of testing things. I do not like that style of testing. Now, I'm not NASA. If NASA thinks it's fine, I guess it's fine, but clearly it's not because it just caused a 12-month delay. I don't think you should test like that. And we got into a conversation during Space News, basically, where I got pissed because I don't think that SLS's testing regime is robust enough. And basically the conclusions that I came to was that, you know what? This is harsh, and I'm not saying this because it makes me feel good. Hey, Barrelicious, 73-month resub. I don't feel good saying this, but I think we're coming up with missions based off of institutional knowledge that we do not have. Something like that, Gaw. I strongly disagree with that idea, too. Are they saying that there's no need to test something in flight until people's lives are depending on it? Yeah, I agree. Why would you not do that? If you found problems with the motor control valves during the mission, if there was life support on Artemis 1, this problem would have been fixed by now. Is it really that much more of a stretch to do that? This is what I mean. I can give other examples, like the Artemis Orion ascent abort test, the AA2 test. You know, they're having problems with Orion interfacing with the launch abort system right now. when the launch abort system has already been tested. Artemis 1 didn't fly with a launch abort system because there were no people on board. Maybe if you had that on there, you would have found this problem. So now all of these, at that on top of failure modes being figured out from the Artemis 1 mission, which is basically a qualification test in itself. It's basically akin to a final exam for a class. You shouldn't learn anything when you take a final exam in a class. That coupled with the failure modes that were found during Artemis 1 with the heat shield. Guys, what are you doing? That's a huge red flag. If you're going to get problems now and that are causing year delays, that are enough of a problem to cause a year delay to the mission, how can you have confidence in that you wouldn't have problems during Artemis 2 or Artemis 3 when people are on board? Yet they sit here and circle jerk about how safety is their priority. Dude, if safety was your priority, all these systems would be tested already before you put somebody on the capsule. I'm sorry. Like, I hate to be a dick. Like, it's a real dick thing to say, because I understand this stuff is hard. It's difficult. I understand these systems are difficult to develop. But is it? Like, honest question. Could this be a symptom of not having the funds to include everything to test? No. No, Talon. They tested everything. We had an abort test. No in-flight abort. Guys, Talon, long story short, the money is there. The money's there. Of course it's there. It's the missions. The missions suck. We've spent as much money on SLS that we would have spent on Constellation had Constellation just kept going. We've spent $30 billion since Constellation has been canceled. That was their price tag. They said, oh, we can't spend $30 billion over the next 15 years. And then literally invented a program that does less, that costs the same price. The money is there. Spaceflight isn't that expensive. Money ain't the issue here. The testing regime. The testing regime in the integrated mission architecture is ass. It's terrible. Terrible. As someone who works in aviation, safety is the first thing in testing. Yeah, Win. Exactly. That should have been thing one. Not, oh, yep, well, safety is our priority, so we got to delay our rocket by a year because we have to make it safer. Not a good look. Do you think this has anything to do with how compartmentalized NASA is? Cake, I don't think so. I think it has everything to do with the goals. NASA's goals. What the hell does SLS do? Maybe some lunar exploration, right? That's cool. Can SLS put somebody on the surface of the moon? By itself? Rain. The rain answered the question. No. Can Starship put somebody on the surface of the moon by itself? No. Both of those rockets, not that this is a correlative statistic, just some food for thought. Both of those rockets have more liftoff thrust than the Saturn V. They're more powerful than Saturn V's, yet neither of those things can do what a Saturn V can do. That's the problem. That's my thing. The mission architecture is poo-poo. It's poo-poo. Now, I'm not hating on Starship. I think if when SpaceX finally gets a human rating certification for Starship, NASA's going to have to take a good look in the mirror, but that's going to take time. Simultaneously, I want to bitch slap the person that thought that making a rocket that doesn't have a clear viable pathway to the surface of the moon and then calling it a lunar rocket. I want to slap that person. Yeah, I want to slap that person really freaking hard. I don't want to cause harm, just a good slap. Just a good 5-star. You know what I mean? And this is something that's been in the back of my mind. it's been in the back of my mind for a little while. You know, I've always said that I don't think Orion is good enough to be able to do these types of missions. Not that it's a reflection of bad engineering or anything. Orion's great. It's a great piece of engineering. I think it's fantastic. But you don't have a service module that can get down to low lunar. So basically the whole thing from the US, the whole thing about the US getting away from using the space shuttle 15 years ago at this point, right? The whole thing about that was to have something that's safer. Have a capsule. Go back to using an abort system. So if something does go wrong, you can get away with it. You could get away from the vehicle at any time. The crew can eject at any moment. You couldn't do that with the space shuttle, right? And we saw the results of that. That ended well, right? So we switch back to capsules. So we switch back to this, well, you know, we switch back to this whole thing. And the way we designed SLS with the gateway architecture, if something goes wrong with the lander, anywhere between the gateway, rectilinear halo orbit, and the surface, you're screwed. You're screwed. Capsule can't come and get you. Orion doesn't have enough fuel to get down near the lunar surface. It has to stay in this weird eccentric orbit, right? So somehow, like at least with Apollo, at any point they could abort in the ascent module. Like say they were going to land and they saw they were going to land on the side of the cliff and they had to abort. The ascent module jettisons from the descent module hits the surface, the ascent module can get back to the capsule. And if the ascent module runs out of fuel, the capsule can go and fish it out. It can go and get it. Because the CSM could pretty much go almost anywhere that the LEM could go, with the exception of doing the landing burn and going down to the surface. That's good redundancy there. And then on top of that, the CSM has enough delta V to even fish down a little bit, pick up a stranded crew potentially in low lunar, and then have enough delta V to get you home. Orion can't do that. That calls for a much more complicated lander. And even then, there are points where the lander's landing site doesn't necessarily line up with gateway. There's blackout periods for ascent. So we just swap blackout periods on Earth ascent for lunar ascent. That's dangerous, man. I don't like that. I'm not good with that risk. But then again, I'm not NASA, you know? Yeah, Scary, it's true. It's true. Do we think Destin got them thinking? It's possible, Pop Bear. Possible. I think the failure modes and the holes that got burned in the heat shield for Artemis 1 are a much bigger red flag than anything Destin could say. Think about it, dude. A year delay? A year delay. That failure mode that they saw with the heat shield coming apart is serious. That's a big problem. Also, hi, Scary. And you're absolutely right. Apollo is ingenious. It's ingenious. Now, I thought you can get from the gateway to low lunar at any point. You can, not with the Orion capsule, you can't. Doesn't have enough delta V. Orion just has enough delta V to get to gateway. Can't go any further than that. Correct me if I'm wrong. Does the Orion run on hypergulls? And if so, do you think gateway might store that fuel and transfer to Orion if needed? See, Kraken, how would you transfer fuel to the service module when there's a Orion capsule in between the service module and gateway? Even if you could do prop transfer, how would you do that? You want a hypergolic line going through the capsule? I don't. Why is it taking this long Why is it taking them this long to say something, though? It's been over a year since Artemis 1 came out. Because they had to do analysis. They had to do the analysis. They saw some of the heat shield came off, and they had to figure out why it came off. And then compare that to their analytical model. And when they realized that the heat shield delaminating, the deviation in engineering was too far from their analytical model, that, well, now you got to go test again. My question is, what's the next test? How do you remedy this problem without doing another flight test? So they're going to implement changes. They're going to implement fixes to that heat shield. And then they're going to put people on it on the next flight. Okay. Oh, you want to roll like that. Didn't you guys say that safety was your priority? Wait a minute. That doesn't sound right to me. Unless I'm missing something. I'm not obfuscating this on purpose to make a point. I genuinely do not understand. Because up until this point, we've believed them, right? You know, everybody said, oh, what if SLS has a problem? What if SLS has a problem on the first try? What if SLS didn't have a problem? Believe it or not, SLS is not the problem here, right? They said, you know, we will, you know, we'll get Orion to work on the first try. Everything will work great, and then we'll put people on the next flight. Okay, that's fair. I would only put people on the next flight if the first flight went about as perfect as you can go, and it didn't. Why did we choose to go to Gateway anyway? Sustainability. What are the key points of Destin's conference? Adam, the key points of Destin's conference are the Artemis program, quite frankly, even with Starship, has a much more complicated integrated mission architecture. Okay? It requires in-flight refueling. It requires Starship launching. It requires the human landing system to be refueled a bunch of times, then sent out to the moon. It requires the Orion capsule to rendezvous with Starship, and then the Starship to go from rectilinear halo orbit down to the surface of the moon, land, stay down there, come back up, redock to Orion, transfer into the Orion capsule, come back and land. That's a complicated mission, especially centered around 12 to 15, SpaceX said 10 refueling flights, so that's 12 missions total, right? One for the depot Starship, one for HLS, 10 refueling flights. That's a really complicated mission architecture. Apollo, Destin's point was that Apollo, with a blank check from Uncle Sam, right? So basically unlimited cash. The Apollo program had a much simpler architecture than what we're working with right now, and people still died. His point was that unless we pull our head out of our ass and start being a little more real about how complicated this architecture is, we're going to have some big problems. That's what his point was. Now, the reason why I'm so annoyed and the reason why this really pissed me off is because up until this point, you know, like I said, okay, I'll take the Orion abort test, all right? The Orion AA2 test was a really cool test, to be honest with you. It was really sweet, right? They had the launch abort system for Orion and its payload and the fairing for it with a boat tail piece and a Minutemen first stage, an ICBM first stage basically shoehorned in the back. Does the AA2 test have a real service module? No. Does it have a real Orion capsule in it? Nope. Is the launch abort system real? Yep. That's it. Didn't even have a real Orion in it. Now, okay, up until this point, I was like, okay, yeah, that makes sense. You don't really need a full Orion capsule here. Just a boilerplate will make sense. That's fine. A boilerplate. Why would you waste a real service module here and a real Orion capsule? Right? Why would you do that? What if the test goes wrong? That's fair. I think that's completely fair. The abort ascent test went off without a hitch. The boilerplate capsule that the abort system jettisoned basically crashed into the ocean. They didn't even give it parachutes. It just fell into the ocean. It's at the bottom of the Atlantic Ocean near KSP. And I'm cool with that. If that's how you want to do that, that's fine. But if you want to do that way, and then a couple of years after you figure out that the Orion capsule doesn't have adequate power systems to be able to maintain control in an abort scenario, basically Orion doesn't have enough batteries to make all the systems on the abort system work correctly, from what I understand. You're figuring that out now? I don't mind this type of testing. I don't mind this bare bones testing. We don't want to put an Orion capsule in it because it's a waste of an Orion capsule. Well, that's fine. But that only really makes sense if you don't run into interfacing problems between your abort system and capsule when you go to put people on it, which is what's happening right now. They talked about that in the press conference day. I forget when. I was just listening and seeing daggers, man. It really pissed me off. Did Little Joe use a real Apollo capsule? Does it look like they use a real Apollo capsule? It may have been a boilerplate, to be honest with you. But I don't think so. Maybe. I mean, maybe. But even if Little Joe 2 Sea Kraken did use a boilerplate capsule, I'm pretty sure it used a boilerplate capsule. That boilerplate capsule had parachutes on it, so at least you got a parachute system test out of it. And if it has a parachute system on it, that means that there's an AGC inside of that thing. A primitive version, but there's an AGC in there. But also on top of that, they didn't put the CSM on top of the Saturn V and send it. They put the CSM on a Saturn I first, with a pure O2 environment inside, and then a wire shorted out, and congratulations, you made a gigantic pressure cooker. Lovely. Oops. And even after that, they put it on a Saturn 1B and launched that into space. And then they put it on a Saturn V and then launched that into space. And like, the point is that we had more integrated testing. There were more flight test opportunities with the abort system, right? And you can test the floating system. Sure, yeah, Adam, absolutely, right? Right? Is that the abort test that failed successfully? The Little Joe 2 the Apollo capsule, the CSM abort test, yeah, that failed, where the lift rocket actually blew up and it triggered the abort system. Yeah, it worked great. The point is that there was even with the Apollo program, there was way more robust testing of each system. This bottom dollar nickel and dime nonsense that NASA is doing now, I wouldn't have a problem with it if it worked. My problem is that today they basically said, oh yeah, none of the testing up until this point is, I mean, a lot of the systems work, and we learned a lot from the blah, 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 blah. But safety is our number one concern, and we have to address these problems in the program. Like, dude, are you kidding me? The short story of this is that the way SLS is being tested, you should not be running into these problems right now. NASA is literally, and I mean this literally, they're not reading their own manual on how to manage a space program. SLS violates almost every rule in this system, in the Mission Architecture Systems Engineering Handbook. Like, it's a good deal of them. I could cite specific sources if people want me to. Funding right off the bat. And this drew me to a conclusion as follows. Do we think we're that good? We think we're that good? We seem to think that we're that good, that we could just put people on a capsule on the second flight of said capsule and get people to the moon and have it be 100% successful. We think we're that good. Are we actually that good? Because the testing would suggest otherwise. What's the name of that book? NASA Systems Engineering. Guys, let me put it this way. SLS is going to fly. And SLS is using heritage components. It's made out of shuttle parts. So we have a lot of good data behind it, right? Let me put it to you like this. Not even the Saturn V flew with people on its on the second flight. Not even, no. Third flight. And even the third flight, there was no lunar lander aboard. Not even the Saturn V flew with people on it. On the second flight. Third flight. And on top of that, the command service module was tested in low Earth orbit on Apollo 7. So the CSM had flown and had some flight data behind it. Do we really think we're that good? Because once again, the testing and the delays would suggest otherwise. Like, I'm sorry, I hate to be this guy, and I really don't like dumping on NASA, and no, I do not know better. I want a genuine answer to this question. Yeah, Nader, this is... Why do we think we can test spacecraft this way? The testing results themselves suggest that this is not a good way to test things. You shouldn't go for your final qualification and have enough of a deviation in your heat shield analytical model to warrant a 12-month delay to your space program. You know how big of a failure that is? That's a big deal. Overconfidence has always been the flaw when it comes to how Americans go about doing things, yeah, except for the Apollo program. But even then, we still had some casualties. Yeah, Scary, I do. Yeah, on top of everything, on top of what I told you from the press conference, guys, and once again, this is as I understand it. I might have to go back and listen, because maybe I didn't get some of it right, but I'm pretty sure I did, right? I mean, they already laid 12 months, so things can change where they may want another test flight before the manned flight. Steets, I would certainly hope so. I'd certainly hope so. We didn't hear anything about another uncrewed test flight, though. Yeah, Scary, that whole freaking party. What a joke, dude. Look, man. Everybody tests things in different ways. That's fine. Your testing criteria is stringent upon your stakeholder expectations here. So, let me use an example. Using cars. Didn't see that coming. I need a car to be able to get to 100 miles an hour. All right? How would I test a car getting to 100 miles an hour, right? Could I test it in the wind tunnel? Could we build some of the car and then see if that goes to 100 miles an hour? Right? Or do you build the full thing and then go and test the whole thing? Well, if you build out the entire car that's designed to go 100 miles an hour, so 160 kph, if you build out the whole thing and then you test it, you best be sure you did your homework, because if you're driving down the road at 100 miles an hour and something on this car breaks because it wasn't tested, you're dead. You're dead. So it would make sense to test all your components. Do you build out the chassis of the car and then maybe use another car to push that chassis to 100 miles an hour to see if it can go, to see if the chassis breaks or something? Make a test rig for it or something, right? And then once you have an operable prototype, send it to 100 miles an hour. Now, does it get to 100 miles an hour every time? Does it do the same thing every time? That's robust testing. What NASA's basically done is they opted for a type of, basically there's a bunch of different ways to test it. The way that NASA opted in this analogy is to build out the entire car, test every single component, and do all the analysis that you possibly can on the entire vehicle, build one complete car, and then get it to 100 miles an hour. And it got to 99.9 miles an hour. Is 99.9 close? Sure. Sure, it's close. But it's not 100%. That's not what you set out to do. That's spaceflight, man. Can't be 99% good. It has to be right. If it's not right, it's not going to get where it needs to go. If you have 99% of the delta V required to land on the lunar surface, well, guess what? You're going to be eating some lunar dust when you slam into the ground on the moon going 150 miles an hour. We'll say meters a second because Kerbal. See what I'm talking about? That's a huge red flag. I don't really mind the way, like, different companies and different places go about testing things in different ways. And they choose kind of a testing criteria, right? They chose kind of a testing criteria here. The testing criteria that NASA chose basically means the car should have gotten 100. It should have got to 100 miles an hour on the first try, and it didn't. Big red flag. That means your testing wasn't good enough. Big red flag. That's why SpaceX's iterative prototyping is genius. Yeah. Yeah. Yeah, that also is really expensive. But, yep. See what I'm talking about? That's what happened today. They said they wanted to, they said their first mission, they wanted the car to go 100 miles an hour, and it didn't go 100 miles an hour. And so they said, oh, well, we got to take the whole thing apart and check it. And that's going to delay our next 100-mile-an-hour attempt. See, I see that because I've been following pretty closely with SLS's testing, and I see a big red flag. That's not good. It's not a good thing. Shouldn't be getting this kind of surprises at this phase and with the criteria that you set for your testing. It's bad. That's like, I don't mean to doom. You guys know I don't do this, but that's not good. I'm confident enough in my knowledge of systems engineering to understand that this is a big deal. I mean, the delay is self-evident in this regard. A year delay to the timeline? A year delay to the mission timeline. Should NASA keep doing Artemis 1 style missions until they get results good enough for a crewed mission? They made Boeing redo the orbital flight test, Lundprod, because it didn't meet its expectations. Just saying. Heck, they delayed the Crew Dragon mission. They delayed DM2 for a couple of years because the parachutes weren't up to spec. They made SpaceX test parachutes for a couple of years. And Starliner. I've been listening to you, and I know this reeks of get it done quickly, not in the best way. With a year delay, would that hypothetically mean that there's a spare SLS core sitting around somewhere? If their production rate is 1 per year. Couldn't they assign that SLS to an uncrewed Artemis Style 2 mission? Blinga, the way the contracts are set up for SLS core manufacturing, because we don't have a block buy, something that I've been saying for years, because we don't have a block buy, is we only have a finite amount of SLS cores that are allocated for Artemis 1 through Artemis 4. So no. Unless they want to go change in the contract. Maybe they'll do that over the next 10 months. I mean, why launch... You need to test Orion's heat shield from a highly eccentric orbit around Earth to get the proper EDL testing criteria. Why not just contract SpaceX or ULA with Vulcan or something to punch an uncrewed Orion capsule into a geostationary transfer orbit and then re-enter from there, and do a re-entry that way. You don't even need SLS to do the heat shield testing. Basically, a year isn't enough to manufacture another SLS core, and since the program basically called for producing the exact amount of SLS cores that were needed for the missions. Maybe they could shift some stuff around. It's possible. But that would screw up missions that are already in motion, even with the delay. Could Falcon carry an Orion? I thought the Orion diameter would be too large. SpaceX could whip up an adapter. No problem. Orion's too heavy for Vulcan. Guys, all right. No, it's not. It's not. Vulcan could get it into orbit. VC6 Vulcan could get it into geostationary transfer. Absolutely. Do you know how I know? Orion has a service propulsion system on it, guys. The SPS can be done for final orbital insertion. Same with Falcon. Hello? Guys, you forget that Orion isn't just a payload. It has a kick stage. It has the service module. Gotta slap a big flag on there, right? On this thing? Oh, yeah. Yeah, we do. But does that extra SPS go? Is that extra SPS going to cost a year? Yeah, with the scary. I don't mean to be candid, but I'm kind of pissed with the frankly Bush League procurement methods that I called out freaking 5 years ago. Yeah, it's gonna screw up the timelines. Yeah, absolutely. Basically, they won't be able to make another SPS in time for Artemis 2 to go off, even with the 2-year delay. I told you this procurement strategy is Bush League and could come back to bite us. I said this in 2018. I said we needed to block by SLS cores. I said that. I said that needed to happen. If we had done that, these tests wouldn't be that big of a deal. I've been saying you need to up the flight rate on SLS. You need to up its flight rate. Okay? I don't understand how somebody in the same breath could say that the Apollo program, launching 2 to 3 times a year at its peak, could somehow be less sustainable than a program that warrants one super heavy launch to the lunar surface, one super heavy launch vehicle launch every year. Probably less. How in the hell do you think that is more sustainable? Are you kidding me? Dude, this has been brewing for a little while. I've noticed things. And maybe I'm wrong. I hope I'm wrong. Maybe I'm overreacting. Dude, that is the best thing that I can hope for, that in like a couple of weeks' time, this comes more into focus, and I sit here on the stream and say, yeah, I was wrong. No, I don't understand. I didn't get all the information. That is the best case scenario in this, me looking like an idiot. That's what I want. Because that means that NASA didn't screw up as badly as I think they did. You need to make a multi-flag to get that insane fire on the booster. Yeah, right. $30 billion. Been saying it for years. Sorry about the bad news. It's okay, Chris. It's all right. The year delay is likely from the remove and replace of the circuitry for the motor control valves on the life support system, not the heat shield investigation. They found it when doing acceptance testing for the A3 hardware. That means they likely found it pretty recently. Novus, I have a question. Why was the A2 hardware, why did it pass acceptance testing? The motor control valves. Why did that pass acceptance testing and the A3 ones didn't? I'll be honest, man. Huge red flag. Huge red flag. How did one pass and it didn't? Did you change them? Are they different? Did we change the testing criteria? If so, why would the life support system acceptance criteria be different between 2 and 3? See what I mean, dude? I understand the heat shield, and I understand you're gonna get surprises. I get it. I get that happens. I'll be honest with you. What I heard from Bill and the rest of those guys today does not instill high confidence. I'm not like this. I don't do this unless I think it's really warranted. Right? I generally don't badmouth NASA. I really don't. I don't like doing it. This is the first time I've done it in a really long time. I hope not passing. Dude, talk me out of it. I hope I'm wrong. I hope I'm not looking at this right. In which case I flipped out for nothing, which is what I want. It could be that the 2 missions have different requirements due to the length, environments, loads, docking, interfacing with other components, etc., etc. There could be a whole bunch of reasons for the difference in requirements for qualification and acceptance testing. Yeah, I understand it. Artemis 2 has it's a different mission profile. I get that. But okay. This is the thing that's really starting to be a thorn in like my mind, dude. Hear me out. And once again, armchair engineer, I get it. I'm hoping that you have the answers to all my questions, man. Like I'm not trying to put pressure on you. Like, okay, so all right, why wouldn't in this particular case the acceptance testing for Artemis 2 and Artemis 3 be the uniform requirements for Artemis 3? Wouldn't you want a baseline for your life support systems? Right? Like, wouldn't you want a baseline for that, dude? Why would the acceptance testing be different? The whole point, like, you're getting some flight-proven data, but your environmental control systems, if the requirements are different between the second and third mission, how can you correlate flight data? Like, how can you say Artemis 2 was successful and not Artemis... Like, see what I mean? Like, why wouldn't you build it out for the mission that it's intended to do? Like a long-duration stay at Gateway. Why wouldn't you build it out for Artemis, like Artemis 3 or 4? Yeah, scary. Yeah, I gotcha. I'm curious. I'm wondering, like, what is the logic behind this? Yeah, SKS, that's my question. Well, Joe, I'm asking people that that are smarter than me. Give me 1 second. Yeah, Broccoli guy. That's why I'm asking. Yeah, Fatal Owl. See what Blinga said. Yep. Can we need NASA for an answer? It is likely built out for a box of conditions that they expect, with margin that encompasses all the different mission profiles. Remember, on Artemis 1 when they stressed the cooling and solar panels with the orientation of Orion, it could be that the campaign for 3 exposed a problem that 2 didn't catch. You won't get arguments from me that the life support system should have been further along in the pipe than Artemis 2. Okay, cool. Yeah. Like, I guess Nova's the big thing from this, that the big thing that I've been able to pull away is that the style of testing that they're doing is it seems to be very Spartan, I guess, right? Like, Novus, before you got in here, I used the Orion ascent abort mission, right? Did you do an in-flight abort with SLS? No, well, you're not going to do that. That's too expensive, right? You know, I understand putting it on, launching it from Complex 46 with a Minuteman first stage shoehorned up the tailpipe and go, right? But that wasn't even a real Orion capsule, right? It was just a boilerplate. The capsule didn't even parachute down. There could have been, you could have had an opportunity there for recovery, but for like testing the integration between the Orion capsule and the abort system, right? And now you have problems with Orion interfacing with the damn abort system due to power consumption needs. Like, why wouldn't you do that way? Yeah, SKS, I mean, if it was me, cost be damned. If you're really about safety, the Artemis 1 and Artemis 3 Orion capsules would be identical. Just putting it out there. Like, it's really starting to, like, it's pissing me off. Like, I don't mind that style of testing. You know, you do an abort test with just the abort system, no Orion capsule, right? If you're going to do that, your QA on the ground, your testing up until like Artemis 1 should be spot on. And if you get it right, then yeah, that testing regime was fine. Like, I don't get it. SpaceX sacked an entire Falcon 9. They sacked a Falcon 9 first stage and second stage. They sacked an entire Falcon 9 to do an in-flight abort.
Go at throttle up.
Now, don't get me wrong. SpaceX's testing criteria called for an in-flight abort. SLS did not. That's fine. As long as you adhere to your testing criteria, I don't have a problem with that. But it's very clear that that's not what's going on here. Yeah, Porter. Porter with a 102-month resub. But yeah, SKS, that's the point that I'm trying to make. Personally, I would have liked to have seen Eccles on A1. It's difficult to spitball without being a fly on the wall for some of those conversations. I would assume they're doing what they think is best at the time. They make the decision with inputs from whomever they need. I guess. How are they going to deal with the dark side of the moon if they can't even power everything for an abort a minute or two in flight? Different stages of the mission, Sea Kraken, and none of the Artemis missions call for going to the far side of the moon, believe it or not. None of them. Not even missions to Gateway. That's why Gateway exists. Gateway is in a style of resonant orbit, the rectilinear halo orbit, that never loses line of sight with Earth. It uses lunar precession every orbit to change the longitude of ascending node, so Gateway will always have a line of sight with Earth. That favors polar landing sites. Guess where we want to land for Artemis 3? Poles. We're always going to be in line of sight with Earth. That's the whole idea. No blackout. Navy ships get the crap eaten out of them during shakedown. Orion should be no exception. I agree. And it's funny because that's what they did with SpaceX, and that's what they're doing with Starliner. NASA's being super stringent about it, and making them retest, and making them retest, and making them retest. Look, the writing's on the writing's on the wall, man. It speaks for itself. And once again, you're supposed to learn new stuff when you fly, right? If you learn new things, that's cool. You're not supposed to learn new failure modes for your capsule when you fly. Right? That's no good. You shouldn't do that. And for the most part, Artemis 1 was pretty damn successful. So I do, I think the SLS is great. SLS performed fantastic. We should launch it more. I've been saying that for years. But if you're, the heat shield problem, and then there's problems with the environmental control systems, and there's problem with power consumptions for launch abort. Dude, what the actual snot? The way that they set up testing for this dang capsule, this shouldn't be happening right now. Why are we assuming the requirements changed and not these two different sets of valves? You wouldn't change hardware for different mission criteria, Wisp, unless you absolutely had to. That's the logic taken from this. It's just very strange to me, dude. Like, it's very clear that their testing regime isn't good enough for their own stakeholder expectations, and that's no good. But yeah, once again, I don't like bad-mouthing NASA. I don't like doing this, but like, Novus, dude, I've been getting asked questions for years. Well, why isn't there life support systems on Artemis 1? Why don't we test the Orion capsule in low Earth orbit? People ask me these questions anytime I talk about SLS and the missions and stuff. It happens every time. And I've always said, well, that's their testing criteria. They make the expectations and they come up with the testing to They basically set the rules for what they want the mission to be, right? And then they test accordingly to those rules, and they'll find the best way to do it. But this life support acceptance testing parts, the motor control valves on the environmental control systems, if it's enough to warrant a 12-month delay, that tells me that's a big problem. A year delay? That's a big deal. I have to ask, just at the very least as a curious mind, why wasn't this tested? How could you miss something like this? Why didn't Artemis 1 have Eclipse on it, right? And, you know, like, I have to, like, that kind of forces my hand to ask these questions, right? Like, it doesn't make any sense. Buck, you have a question about the power issue. Who got the numbers wrong there? Lockheed Martin and NASA. Northrop Grumman makes the abort system. Lockheed makes the capsule. Well, you get different valves from the supply for each mission. One failed. It's possible. Then you got a big QA problem, Wisp. And this is a QA problem that could get somebody killed. So you probably should fix that. Yeah, Kurt, exactly. Yeah, passing. A2 doesn't go into rectilinear halo orbit. It's free return, right? Which might be the reason for the discrepancy in the testing campaigns. But I wouldn't condemn the entire testing campaign for the entire program just because of a few standout problems. Programs are made of tons of different people doing tons of different jobs, doing a lot of different jobs. For example, to say that the testing campaign for the solar panels isn't good enough because the heat shield doesn't make sense. Fair. Yeah. Like, yeah, I suppose. And Novus, once again, I understand you're going to... This kind of stuff is going to happen. That's like the one certainty that something is going to be overlooked. Not overlooked. You know what I'm saying, right? You're going to get deviancy. But the answer to that I would say is that more robust flight testing to corroborate analytical models would be the solution to that problem. And that's something that I've always had a problem with the Artemis program. Flight rate. Flight rate is ass. It's terrible. It's terrible. SLS should launch at the very least once a year from now on. At the very least. But, you know, like, dude, even if we have to do another distant retrograde orbit insertion for an Orion capsule to make sure all this stuff works, that's fine. Right? Like, we should ramp up to 4 flights a year. Yeah, Apollo, Novus is well-versed in this stuff. Better than I am. Way better than I am, which is why I ask. You know? I want to hear this, because I don't know everything, and I understand that. Well, SLS ain't the bottleneck. That's right, it's not. That's right, it's not. It worked excellent on the first try, and it still worked on the first try. It ain't the bottleneck no more. Who saw that one coming? Oh, man. Orange Rocket's always been good, Blinga. It just needs a better upper stage. Give it that EUS. SLS is a Chad tier rocket. Give it the Block 1B upper stage, and you'll really see what that thing can do. Thing's money, man. Even with the shuttle engines, it's money. It's a great launch vehicle. I don't care what anybody says. As civil engineers, my big question is, what happened to the safety factors on these systems? I don't know, man. I mean, no, like I said, this is why I wanted Novus's perspective, Gob, because, yeah. I mean, you're going to get curveballs in spaceflight. That always happens. Like SpaceX with the DM-1 Dragon capsule blowing up on the test stand. This happens. This stuff happens, guys. It happens. We should take that into account, though. This stuff should be taken into account. You should, like... That's the one thing that you can guarantee, that something different is going to happen, and you're always going to learn every mission. So my argument, I guess, is that the testing criteria for the capsule and the launch vehicle, I mean, launch vehicle test criteria was ace. SLS basically just shat on the test criteria. It was perfect. But all of the testing criteria should take into account the fact that you might not get something exactly right. And I think that favors having a baseline configuration for Orion instead of this iterative thing for Orion. And I've suggested this in the past, right? But now NASA's own testing criteria corroborates this. They have to be pretty damn transparent, Chris. Yeah, we have to know the reasons. That's how I know about different component systems. You know? Hey, Stormcrow gifted a sub to Novus. Right on. Anyway. Yeah, passing. I'm not really... Look, man, there's the way SpaceX does stuff where they just put it on the pad and send it. That's fair. Rapid iterative is cool. But there's another type of testing called... they didn't have a name for it at the time. There's another type of testing that's called waterfall incremental. Okay? It's not rapid iterative like SpaceX. You're still doing all-up testing. But you do all-up testing on a condensed timeline to test out fully each component. You know what space program did that? The Apollo program did that. They tested the CSM in low Earth orbit before they sent it to the moon. Because if it works in low Earth, you need to go to the moon, right? At least you know that if you test it in low Earth orbit, that you can get the thing up into space, you're not going to run into a problem. Incremental waterfall testing is what the Apollo program did. It's not exactly what NASA is doing now, but it's not rapid iterative that SpaceX is doing either. I would argue that NASA went through that during the early parts of the space race with trying to get something into space with Vanguard and all these other things. Vanguard, Atlas Centaur, the Titan 1 rocket that blew up on the pad in 1958. By the time they got to Apollo, they could really focus more on doing, all-up incremental testing. Like, with the Saturn 1, for instance, they tested the Saturn 1 first stage first. There was nothing on top. And when the first stage worked correctly, then they put another stage on top of it. Then they put the second stage on top of that, right? And then they tested that. And then they put a payload on top of that, and then they tested that. That incremental waterfall testing is really what we need to do. Like, Artemis is testing stuff in a way that Apollo didn't even test. And like I said, are we that good? Are we that good at this? That we can just take the testing regime from Apollo and be like, no, we don't need to do that. We don't need to. That's too much work. I don't know. Time will tell. Hey, Jamorian, thanks for the raid. Man, it's really raining, huh? Anyway. I could talk about this till I'm blue in the face, guys. I pretty much have. We made decent enough progress on our Vulcan build today. It's not bad. And it's got flag on it, which is pretty cool. Given the merging of various contractors, do you think such testing is even possible without competition? My main argument here, SKS, is that SLS and the Artemis program's mission architecture is ass. It's terrible. It's terrible. Much too complicated. The Artemis program is all about sustainability. It's all about sustainability. It's all about sustainability. Launching once a year to the moon, which is less than Apollo, which is apparently unsustainable, launch to the moon. During the height, when NASA had the proper funding, during the height of funding for Apollo, during the heyday of the Apollo missions. So I'm talking about Apollo 8, Apollo 9, 10, 11, 12, 13, 14, 15, 16, right? 17. They were launching the Saturn V at least 2 times a year. Basically from the early parts of 1969 to 1972, right? So 69, 70, 71, 72. That's 4 years. We went to the moon, so 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Actually, Apollo 9 didn't go to the moon, so take one away. See what I'm talking about? 9 times in 4 years. That's the flight rate we need to be sustainable. Like I said, dude, I've been saying that for years. I don't think Lockheed operates like that, SKS. I'm pretty sure they don't. But anyway, good conversation, dudes. We're getting up to 10 o'clock. We'll work more on Vulcan probably tomorrow. I'm not happy with the progress that we made on this thing. I want to finish it tomorrow. So maybe I think we'll play Kerbal tomorrow instead of doing wing stuff. I want to get this done. It's been 3 days and I've made a bunch of rulers and some fuel tanks. So we'll get this done tomorrow. In the meantime, let's go see who we can raid. Yeah, like I said, not the best news, dudes. I'm not happy about this, and I don't know. It's good to have perspective on it, but it's still pissing me off. Just hit the reset button for tomorrow. Yep. Yep. Off topic, but I got to go see the ULA launch in person the other day. You were right, it was amazing seeing a rocket in person. I'm telling you, Kurt, it's pretty wild. It's pretty wild, dude. Pretty wild. Alright, Middle Ditch is playing some Red Dead RP. Let's go see what Tommy's up to. What is not the issues with the program? Here's the analogy. We want a heavy haul truck. Here's a bunch of pickup truck parts. Yeah, God, there you go. Guys, let's go see what Tommy's up to. If you're a fan of the HBO series Silicon Valley, you might want to go see Middle Ditch. You might recognize him. He streams on Twitch. He's a good dude. Tommy's playing some Red Dead RP. If you do watch Silicon Valley, the guy who played Richard Hendricks, he's a good buddy of mine. He streams on Twitch. Go rate him. He's an excellent streamer. So go see what he's up to, guys, and I'll be here noontime tomorrow. We'll keep working on our Vulcan build. This is great. I do like what we have thus far. This is good. I just got to come up with the engine section. That's probably going to be the most complicated part. So, thank you very much for watching, everybody. Have a good night. I hope you sort of appreciated my rant today. You're probably not going to see me do it again. I don't like doing this. So, I'm just going to go back to being happy-go-lucky EJ tomorrow. Thank you very much for watching, everyone. I'll talk to you tomorrow and see ya.